Testing, testing, 1, 2, 3. Does this work? Can you hear me? This meeting will start in 1 minute. Good morning, everyone, and welcome to the September 26, 2023 meeting of the Science, Technology, and Energy Commission. We have a day chock full of interesting and exciting activity planned for today. We've got a couple of presentations this morning, which we'll get to in just a minute. And then at 1 o'clock this afternoon, after a lunch break, we will be back for a full committee work session on the 12 retained bills, which we held on to this past April and May. And during that work session, what we're going to do is go through the list of bills and decide what bills will need a subcommittee. Then we will appoint a subcommittee. I will appoint a chair for the subcommittee, and we'll go over the duties of the subcommittee as well. So that will be our activity for after the lunch break, starting at 1 o'clock. But to begin our presentations this morning, I would like to call on Representative Tom Corman to introduce our first speaker.
Thank you, Mr. Chairman. Our first speaker is Professor Sarosh Vasogi from the Dartmouth College Department of Computer Science. And I am pleased to say that he is a former colleague of mine. Now, that can be taken in two ways, and I mean it the good way. So Sarosh is quite an expert on AI. He's presented in various places, and I'll just let him start.
Yes, you'll need to turn your mic on, Professor.
Thank you. Yeah. All right, let's see if this thing shows up. Great, thank you. So thank you for having me here. And if you cannot hear me clearly, please let me know and I'll try to speak louder. I'll move the microphone a little closer. I thought I will introduce basically the current advances in AI today and talk about some of the major coverage of AI and talk a little bit about which of the coverage is true, which is false, which is fear-mongering, which is actually something to be concerned about. So I titled the talk AI, what it is and what is not. And I don't need to motivate this for the audience here, but basically, as you all know, AI has been all over the news recently. Some of the coverage positive, some of it negative. So here you can see, thank you. Here you can see some example of coverage of AI that is mainly positive, right? So basically, how AI can help in healthcare, how generative AI can lead to a boom in hiring, and so on and so forth. Just a couple of examples from just this summer. But there's actually a lot more negative coverage of AI. And if you open up any news outlet in recent weeks, you'll see that there's always some kind of a doom and gloom coverage of AI, including some as I guess sensationalist as this article, like is AI really the doom of humanity? So I did a bit of a study where I looked at the coverage of AI and I found that there's a 2-to-1 basically bias against AI. So twice as many articles are talking about what AI, where AI could go wrong. About a third talk about where AI can actually help humanity. So there's a lot of fear around AI. And so what I want to discuss today is whether this fear is justified. And you probably all noticed, but there was a recent meeting at Washington discussing regulating AI, including a lot of the current tech industry leaders like the CEO of OpenAI, Google, and a few other big companies. So this is a really current topic and something that I think is very important for legislators to be at least somewhat aware of. So there's a lot of coverage of AI, most of it, fearful, some of it hopeful. But what is AI? Most people actually will not be able to answer that question. That's because there's a lot of basically terminologies and concepts and topics that you see being covered in the news that are talking about similar things, but there's really no understanding of what is what. So here I have shown you some examples of the topics that you might have read about in recent news coverage of AI. Just out of curiosity, everyone has heard at least half of these, or everyone here, I'm assuming, has at least seen half of these topics being discussed. Is that correct? If anyone hasn't seen at least half of these topics in recent news articles, please raise your hand. I want to see. Right. So this is basically something that's all over the news, right? So artificial intelligence, machine learning, deep neural networks, deep learning, ChatGPT, deep fakes, self-driving cars, all related to AI, but actually very different concepts. Here I've ordered the concepts into two categories: the top category and the bottom category. I hope you don't mind me asking some questions while as I go forward with my talk. But can anyone tell me what they think is the top category and what is the bottom category? So you have AI, machine learning, and deep learning at the top, and at the bottom you have DALL-E, ChatGPT, deepfakes, Alexa, and self-driving cars. Any? Am I allowed to ask questions or? So what is the? So there are two categories: the one on the top and the one at the bottom. What do you think these two categories are? You can see them. So AI.
The top row is AI concepts. The bottom row is AI implementations.
So very good. Yeah. So the top row is basically technologies. Let's put it that way. And the bottom row is the applications of these technologies, right? So AI, machine learning, and deep learning, they're all technologies. ChatGPT, DALL-E, and deepfake, Alexa, self-driving cars, they're all applications. The reason why it's important to separate technology from applications is because, just to show this, as I just mentioned, top row technologies, bottom row applications. The reason why it's important to separate technologies from applications is because, technologies, more or less, you can think of them as being neutral. You can use them for good, you can use them for bad. A car can be used for good, for transportation. We can also use a car to run people over. So technologies themselves don't really have any kind of bias towards being good or bad, but applications of technologies do. So examples that I've given here, for instance, you can imagine some of them being a lot more controversial than others. So for instance, Alexa and Siri, probably less controversial. Deepfakes, very controversial. So this division between technologies and applications is very, very important to keep in mind when discussing AI. A good analogy that I use is, the technology of winged flight. So when the principle of lift was discovered, how you can basically design a wing so that you get higher pressure at the bottom of the wing than top, so that you get lift. That's a technology, right? It's winged flight. applications could be, manifold. Could be civilian applications, military applications, some for good, some for bad. But the technology itself, it's hard to say that it's, good or bad. It's the applications that really need to be scrutinized. So I think it's important, kind of the first takeaway should be that when discussing AI, I think it's important to be discussing applications of AI more than the technology of AI. So even though obviously the technology is what leads to these applications, it's the applications that could potentially be, anti or pro-social, depending on how they're used. Okay, so let's dig a little further in, and let's talk about these three technologies: AI, machine learning, and deep neural networks, or deep learning. So you have three circles here, three sets of technologies, and there are different ways they could be related to each other, right? So let's think about different Venn diagrams you could use to look at the relationship between these technologies. So at the top, you have them being completely, separate, independent technologies. Bottom left, you see them overlapping, so meaning that they're the same thing. Bottom right, there's some overlap between them. I'm curious, the audience, who thinks that the top left, diagram is the correct diagram, where these three things are completely independent? Who thinks the bottom left is correct, where they're all the same thing, just different terminologies? And who thinks the bottom right is correct? Okay, so it's a trick question. None of these are correct, but thank you for participating. The correct representation is actually this. So AI is a term that pretty much encompasses all technologies where you have basically machines mimicking human behavior. That's general definition of AI. Machine learning is a subset of AI, where the mimic of human behavior is done by exposing the system, the machine, to a lot of data. You can think of it as experience, and the machine automatically learns to mimic human behavior from the data that it's exposed to. You can imagine there are ways to create a machine that mimics human behavior that doesn't use data. So for instance, if someone hard codes a set of behaviors for a machine to follow, then that machine, it's still called an AI system, but it's not learning from data, right? That is the difference we're talking about. A good example of that would be, for example, the autopilot system on a plane. The autopilot system on a plane is not a system that's learning from data. It's been hard coded to fly an airplane, basically. If it was learning from data, you can imagine that would be quite problematic, as it could lead to errors and whatnot. So that's AI as a whole: systems that mimic human behavior, machine learning, subset of AI that learns from data, and then deep neural networks or deep learning. If you've heard of it, it's just a subset of machine learning algorithms. I guess the defining characteristics of deep neural networks is that they rely on massive amount of data. That's one. The other is that they remove humans from the loop. So I'll go into that a little bit, but you can imagine if you're using data to create these AI systems, you could either have humans provide the data to these systems, or you could have the systems go and find their own data, basically. And in some ways, that's what deep neural networks do. So there is much less reliance on humans to provide the data for these models. So why do I have this division? Because every application that I showed you, so ChatGPT, DALL-E, deepfakes, all of those are actually fall under the deep neural networks set. So AI has been around for decades. It's just the recent advances in deep neural networks, which is a specific technology that allows AI models to learn from data, from massive amount of data, without much human oversight. These are the models that have allowed, or this is the technology that has allowed these huge advances that we've seen in recent years, like, for example, ChatGPT and deepfakes. So before I go further, like anyone have a guess why deep neural networks are potentially problematic? So, we all know that there are potential issues with, ChatGPT, deep fakes, Dolly, all of these systems. And as I said, they all fall under the deep neural network category. Any reason why relying on massive amount of data and removing humans from the loop could be problematic? Yeah, go ahead.
Garbage in, garbage out.
Very good.
If the data that the network is using is flawed or biased, you're going to get bad actions.
Excellent. Yes. So that's a big one, because if the data is bad, then the output is going to be bad. Yes.
I would just follow with the removing the humans from the loop means that we could have outcomes that are not consistent with what we're hoping to achieve.
Excellent. Yes. Anyone else? Yes.
On a practical application, I'm seeing one that was not on your original chart was facial recognition and the mistakes that are often made in that. Well, 2 mistakes is too often when it
Exactly.
could wreck human life like that.
Yes. Very good. So yes, one more.
I would say whoever controls the data has an awful lot of power.
That's also a great point. Data being the beginning of everything. So if you think of the pipeline of these models, it all starts from the data. So if someone controls the data, then they can basically control the output of these models. So yes, I think these are all great points, and they actually get to exactly what I'm going to get into next. Yeah, so this is just saying that these technologies that we've all seen in recent years, they fall under this deep neural network category. And this is just a visualization of, very simple visualization of kind of the difference between. So again, here, neural networks are a subset of machine learning, and a big difference between just traditional machine learning and deep learning is, as you can see, the removal of human in the loop, right? So traditionally, this is a very simple example. Let's say you have a model that's detecting whether an image has a tree on it in it or not. So is it a tree or not a tree? Very simple model. Traditionally, there was a lot of input. So these are examples of images of trees. There were people like humans in the loop labeling these examples and maybe removing bad examples. Then you would train a model and then you get an output. With deep learning, that human, there's no longer this human in the loop. So this is a big, I think, one of the big advances, which allows for, of course, scaling systems up. By removing humans in the loop, you can do things much faster, but also it removes any kind of oversight that these models usually, or the machine learning models typically had in the past. And this is a very, very, very unrealistic visualization of a neural network, but in case, but it does do a good, I guess, job of at least demonstrating the structure of neural networks. It's a very, again, it's a toy example, but the general idea is that they're called neural networks because the basic processing units in these networks are these nodes we call neurons that are simple mathematical functions. So at the end of the day, these models are not magic. They are basically a cascade or collection of mathematical functions that take data as input. They transform the data through different layers, as you can see here, and then they output some result. At the end of the day, it's just math. But what what is kind of unique about neural networks compared to other AI or machine learning systems is that the input that goes into these systems can just be raw data without any kind of processing done by humans. Again, as we see here. So just input from the raw input from the real world goes directly into these models, both for training and deployment. So it removes the human completely from the loop. Okay, so let's talk about one. Again, this is just a representation of a neural network. Let's focus on one of the technologies that has been making the news recently, which is ChatGPT. It's a the technology itself actually is called large language models or large pre-trained language models. ChatGPT is an application of such a technology. So for instance, Google and other, so ChatGPT is an open AI tool. Google has its own version, Bard, and Meta is going to have its own version soon. So these are just different applications of the same technology, large language models. And as you've all, if you've played with ChatGPT, you know that they can perform many tasks on par with humans and sometimes actually outperforming humans. So it's a great advance in technology. But, oh, and by the way, I put this slide in my talk because even though it's only recently that people have been aware of this technology, large language models, because of ChatGPT, it's actually been out for a couple of years now. So GPT-3, which is the tech, the core, or GPT, which is the core tech behind ChatGPT, has been out for years now. So this article was written in 2020 in The Guardian. It was completely generated by one of these large language models, GPT. So again, it's only recently that because of ChatGPT, it has come to the public's attention, but the technology itself has been out for a couple of years now. If you're interested, you can read this article again, completely written by GPT-3. So it's not new. The technology itself is not new. It's a couple of years old. The applications like ChatGPT, that's new. Okay, and if you haven't used ChatGPT, I really recommend you play around with it. It's free to use, and here's an example of what you can do with ChatGPT. So, if you just ask it, write an inspirational speech about the status of ChatGPT, you can see that it can generate pretty coherent, text based on the prompt. In some ways, it's not really distinguishable from a human writing. Okay. So these issues with the large language models, are exactly as was discussed, garbage in, garbage out. So very nice. That was the first comment. Because they rely on massive amount of data and there is no, basically very little human oversight, if the data is biased, if it's toxic, if it's stereotypical, anything is going to be represented in the output of the model. The model cannot really separate good data from bad data automatically. So that's one of the biggest issues. Humans have been taken out of the loop. There's reliance on massive amount of data, and this data, there's no oversight, basically. It's just publicly available data. We didn't have this problem with other AI models in the past because, as I showed here, anything in the green circle that was not part of machine learning, that doesn't rely on data, right? So there's no issue of garbage in, garbage out. And then even with machine learning models that do learn from data, the kind of classical machine learning models have this human in the loop that allows for providing oversight to these models. It is deep neural networks specifically that rely on a lot of data without human oversight that have this issue. I just wanted to emphasize that point. So garbage in, garbage out, big issue. And the obviously, if the data that these models were trained on were good, then there would be no problem. But as you may know, the data is actually scraped from the web. So it's publicly available data on the internet. And anyone who's been on the internet knows that there's some good stuff, but there's also a lot of toxic speech, hate speech, misinformation. There's just all sorts of things, good things and bad things. But again, these models are trained on everything. They don't really separate what is good from what is bad. And then the second issue that these models have is that they're black boxes. So even the people who work on these models, including my lab, even though we understand the kind of the math behind these models, we cannot really explain why these models make the decisions that they do. Similar to, you can think of it as a human brain. I mean, a human brain, you can, or a human with a brain, you can ask it things and you will get responses back. And you might have behavioral scientists trying to understand how humans make decisions, but it's a big unknown. It's really not known because brains are these huge, complicated systems. It's not really known how exactly the decision-making process works in the human brain. Similarly, these neural networks are huge models that are impossible to really understand. So garbage in, garbage out, black box. And again, it's an issue with deep neural networks specifically because of their size. So garbage in, garbage out, issue with deep neural networks because of the reliance on data and removal of human oversight. Black box, issue with deep neural networks because of their size. And finally, you may have heard this term, but they have a tendency to hallucinate. Anyone heard about hallucinations for these models? So basically, because they're so large and they can sometimes, not all the time, they can combine what they've seen in the data in imaginative ways to output something that sounds plausible, but it's not. So for instance, DALL-E, which is, if you're not familiar with DALL-E, it's an image creation tool. So you basically write in a little prompt and it will automatically generate an image that matches the prompt that you've written. So if you ask it to create an image of a cat, sometimes it might, and I've seen this myself, it might create an image of a cat with like 3 heads, right? I mean, that's just a very clear example of hallucination, but it's not limited to image only. Also text systems like ChatGPT are prone to hallucination, which means that they make up information that sounds correct, and the models, that's the difficulty here is that the model itself thinks the information is correct. So the model is not trying to deceive the user. The model just thinks this is correct, but it's hallucinating. So it's not correct. And again, this is a problem that is very specific to these deep neural networks. So I've identified 3 of these issues, but there were a few others that were mentioned, which are also very important. So let's take a little, dig a little bit deeper into these 3. I'm going to show you a little bit of math here. I hope that's okay. But I just want to really explain when I say these models are large, what I mean by large, because it is the size of these models that make them black boxes. So as I said, machine learning models are not magic. They're basically just mathematical functions. You can think of a line, like a simple linear regression line of best fit, as a very simple model. It is a mathematical model that can make predictions, right? So you have a line of best fit, you learn a line of best fit, now you have new data coming in, new X, you can predict Y, right? That's a very simple machine learning model. It's trained on data, right? That use the data to learn the line of best fit, and you can make future predictions. It's a very simple model. It's a machine learning model. A simple line like this, how many parameters do you think this line has? What is like an equation for a line? Anyone remember from high school? Not Tom. Anyone else? Yes. Oh, very good. Yes, it does have 2 parameters. And what are they? So yeah, so it has 2 parameters: the intercept, exactly, where the line is intercepting the y-axis, and the slope of the line, right? If you remember from high school math, y equals mx plus b, m being the slope, b being the intercept. Doesn't matter the math for it, but the idea is that it has 2 parameters, specifying the intercept and the slope of the line, right? So this is the equation for it. M and b here are the 2 parameters. So these 2 parameters explain this model. Okay, now how many parameters do you think these deep neural networks have? So if a simple line has 2 parameters, how many parameters do these deep neural networks have? Millions? Well, at least 10. That's a good answer.
John, don't forget to use your mic.
I think it goes back to Shannon. Basically, the number of points that define a waveform, and the bandwidth has to be, you cannot define a waveform with less than 2 points. Yeah, and it's fuzzy, but I think it comes back to Shannon.
So for a line, 2 points for sure, but let's now take a step back and like a neural network.
Excuse me
which
one
is-
second. I couldn't understand what you said. You started with a line is defined by 2 points, and then you said how many points is it take to define something? What was the something? I
Oh,
didn't
I'm
get
sorry. So let me rephrase that. So A line is defined by two parameters, the slope and the intercept. And as I said, a simple linear regression is a machine learning model, right? It has two parameters. Now, how many parameters do you think a deep neural network like ChatGPT has? That was the question. And I think there was someone said millions. Who was that? So millions is a good guess, but it's actually a lower bound. So it's actually hundreds of billions of parameters. In fact, the current GPT model that's going to be released soon, GPT-5, is the first trillion parameter models. Trillion parameters. So that means that a line, you can understand it. It's interpretable because it has two parameters. It's the slope and the intercept of the line. You understand it very well. Now imagine if you had a model with a trillion parameters, right? There's no way we can understand how it works. So even the people who work on these models have very little understanding of how they actually work, because we cannot imagine a trillion dimensional space, right? It's just outside the scope of our understanding. This is just to make the point about what makes these models black boxes. It's just the fact that they have so many parameters, trillions or hundreds of billions, that it's hard to figure out exactly what's going on inside these models. That was the point I was trying to make. Sorry, but yes.
I'd just like the record to show that trillions is a bunch of millions.
That is true. So hundreds of or millions of millions, yes. So yes, current models have hundreds of billions, and again, as I said, the newest one is going to be the first trillion parameter model. And this came from 2022, but Google's Palm model, this is 2 years old already, had 550 billion parameters. So now actually, if you see this, you know what they're talking about. So when they talk about the number of parameters, they mean the number of mathematical parameters that explain the model. And in this case, it's yes, go ahead.
Is a parameter something that's associated with a sensor that's bringing in data?
Could be, depending on your application. If you have sensors bringing in data, yes.
What else could it be?
Well, it's more a function of the model itself, not the data. So the same data. So let me give you a very simple example. ChatGPT deals with text. Text is the data. The model itself has billions, hundreds of billions of parameters, but I could come up with a very simple model with a few parameters that also deals with text, but it's not going to perform well at all because it's yeah. Let's put it this way. It's a system-specific number, right? So ChatGPT being a system, it has that many parameters, right? DALL-E has these many parameters, and so on. Does it make sense?
It makes sense. I'm just trying to get a sense of what limits the
There's
size
no-
of the parameter.
That's a really good question. So the limit is how much data you have to train your model. So the more data you have, the more parameters you could have. And also your computing infrastructure. There is a reason why these models are coming out of kind of big tech companies and not academia, because only Google and OpenAI and Meta actually have the computing resources to learn these things. At Dartmouth, for example, the best you could do is a few hundred million parameters, like maybe a couple of billion, but nowhere close to what is. So I'm going to move on just to. For the
Excuse me,
interest of
I
time.
just
Yes.
wanted to follow up on this
Yes.
thing you had here with the hallucination. Now, I understand, you say you can put something in there and it'll generate a picture of a cat with 3 heads. That becomes obvious. Well, that's not a real cat. Everybody knows that. But what if it generates something much more complicated than that and data? Then how does one determine if that's hallucination or not? Because people are going to look at the outputs of these things. People say, oh, I read it on the internet. It was under this. And so it's real, but it's actually artificial. So is there any way of running it through a second scenario or some way of checking that to determine what's real and what isn't?
That's a really good question, and something that my lab and others are working on right now. The answer is currently no, and that's why it's a big issue. Unless it's obvious, like you said, like a cat with 3 heads, There's no way, because the model itself thinks that it's true. That's the problem, right? And so it's actually, there's no way to automatically figure out whether something is a hallucination or not. And that is a huge issue. I'll actually get to that in a second, but
But just, I just
yeah.
want a follow-up question. So would it be possible to run it through Model A and it comes out with some set of data and says this is all facts and we think this, the model thinks this is all correct? If you ran it through a separate model that was different and they didn't come out the same, would that be a kind of a key indication that one of them was wrong? At
Yes,
least?
so that's a really good suggestion. It would at least tell you that there's inconsistency,
Right.
but it won't tell you which one is right.
Right, yeah, I understand that. Just-
But another problem, but that would be one way to do it. There are a couple of issues with that. One is that there are only a few of these models out there because, as I said, just because of the size, there are only a few companies that actually can make models like that. And secondly, they're all trained on publicly available data from the web. And so the kind of this garbage in, garbage out principle, that they're getting the same garbage in. And so, they don't have independent data sets that they're trained on. And that is a big issue.
And in fact, it could be created
If I,
next
if
round.
I could just
Yeah,
interrupt
okay.
for a second,
Please.
Representative Harrington, let's save the questions for right after he finishes his presentation, which is going to be real soon now, right?
Yes, yes.
Okay.
Thank you.
Thank you.
All right. So I'm just going to talk a little bit about the garbage in, garbage out, and the hallucination. I can skip this for the interest of time, but I just wanted to at least provide some, understanding of how these large language models work. It's not, as I said, magic. It's all it is. It's what the model has seen in the past. So let's take an example of at the very bottom, right? So as I said, large language model is a technology that ChatGPT and other tools use. So you can, for the red box, you can just think it says ChatGPT. Now, if you pass as a user, if you write, I was walking down the street and pass it to ChatGPT to complete, it could finish your sentence to make it some coherent thing. So I was walking down the street and then it would generate when I saw my friend. For example, it's just a very simple example. That's how these things usually work. They take a prompt and then they generate text based on the prompt that you've given. The way these work is that based on the data that they have seen, so this is the data from the web, they have a probability distribution of which word should come next based on what is already being said. So you're talking about, I was walking down the street, so this is what already being said, and now the model has a distribution of what is the most likely word that comes after this series of words. And here I'm showing you, this is a toy example, but you can imagine the model, so the bar being the probability, the model thinks that, okay, when is pretty common, and is less common, at, is even less common, and so on. And it randomly picks one of these choices based on this probability distribution. So it's not that each word has the same likelihood of being chosen. When is more likely to be chosen than and, because it has a higher probability, right? But it is, at the end of the day, randomly chosen. This is important. That's why if you pass the same prompt to ChatGPT, you can get a different generation every time, because it could be picking a different word every time. And then once it picks the first word, now the prompt becomes, I was walking down the street when, and then again it looks for the next word that is the most probable word. So when I, and then so on and so forth. So this is a gross oversimplification, but it's a good intuition to have around how these large language models work. They are at their core next word prediction models. They predict what word should come next given what's already being said. And that prediction is based on what they've seen on the web, right? So why am I telling you this is because, well, if what they've seen on the web is garbage, then their predictions are going to be garbage too. So garbage in and garbage out. And then finally, hallucination, we already had a discussion around this, but a really good example of this is this case that, I don't know if you've heard of this, but in the summer, there was this case where a lawyer in New York basically wrote his whole legal brief using ChatGPT, but it ended up, ChatGPT ended up hallucinating a lot of legal cases that didn't exist. So it basically, cited a lot of, it cited legal cases that didn't exist, including proper citations and everything. And the judge was looking for these and they couldn't find it. And anyways, the lawyer got into a lot of trouble. But that's an example of a obvious hallucination, right? It looks legit. Citations, like the citations even included, years and authors, everything. And they made sense for someone who actually hadn't seen the citations. They made sense, and that's a really good example of hallucination. I think for the interest of time, I can stop here and then take more questions.
Well, I want to thank you. I know this is an incredibly complex topic, and you did a great job of condensing it into something that we could understand and absorb. And I know the committee has lots of questions for you. Unfortunately, we only have 20 minutes of questions before we have to call it off, but I will ask everybody to raise your hand before speaking, and then I'll call on you to ask a question of the professor. So we'll go with Lucius Partial first. Oh, a question of me. Okay. And we're breaking at 12. We have another presentation at 11. Okay. Representative Wendy Thomas.
Thank you. What kinds of laws are you seeing that are specific for AI and in particular in the political world with propaganda?
About the use of AI for propaganda?
Just the use of AI in general. Are you seeing any specific laws being generated?
Yes. You may know that EU is actually, like Germany was one of the first countries to specifically regulate the use of ChatGPT for public employees. And if I'm not mistaken, I think even the state of Maine had a hold on the use of, and others can check this for me, but basically public employees are not allowed to use ChatGPT for the next couple of months as they figure out basically what's going on. I believe that's correct. State of Maine, so neighboring state. And in terms of other laws, well, there's a lot of discussion in EU. I think EU is definitely leading the way for laws and regulations. I do want to make a point here. This is my own personal opinion, which is if you're thinking about laws and regulations, it's important to have this distinction between application and technology, right? I don't think regulating the technology makes sense. Maybe regulating the application of it makes sense, right? So you don't want to, stop innovation in AI. That's the technology. But yes, applications of it, I can imagine, potentially be something that could be regulated.
Representative Summers.
Thank you, Mr. Chair, and thank you for taking my question. Being a network engineer myself, I'll be the first to admit I use ChatGPT, and I've even cheated and downloaded Python code to create an API. So it does work. But the question I had is that I have noticed also on searches you can get a as of 2021, this is not known to happen. Is there I can guess there's never going to be absolutely current. Is there like a set timeline of how out of date the data would be in API?
Yeah, that's a great question. Because these models are so large and so expensive to train, you cannot retrain them often. And I believe ChatGPT, actually, if you look at the very bottom, it says like when was the last time it was when was the time frame that it was trained on. I believe the most recent one is 2022. But that's a really good point, which is because these are trained on large data sets and let's say they're retrained every year, that means that they're actually behind in terms of what is common knowledge and common understanding. Yeah.
Representative McWilliams.
Thank you, Chair Vos. Thank you very much, Professor, for the presentation. I have a question about blockchain in terms of using blockchain as part of proving where data comes from, and by extension, if there is anything we can do to set rules for blockchain to prove data, for just as an example, deep fakes, right? Blockchain would dissolve the underlying supports of a deep fake because it proves that it's not actually based on the truth. Is there a way for us as legislators to implement blockchain checkpoints to make sure that moving forward, what we're seeing is the truth? Thank you.
So, yeah, thank you for the question. I have to say blockchains are definitely outside my area of expertise, but I can comment a little bit on it, but I can't comment on the technology much. What is true is that blockchain can be used to, in some ways, watermark, data. And so, and I know people have been talking about it with respect to deep fakes. So in some ways, you can imagine, having a built-in verification of, all right, is this a real image or is it a generated image, right? And I know there are, people who are working on this, again, outside my area of expertise. I do know that this is much harder for text. So for image, it's much easier than for text, because you can imagine it's hard to watermark a piece of text. And there are, again, discussions around this, so maybe, you have some kind of a, I don't know, like mathematical function encoded into the text that to the naked eye, it just looks like a normal piece of text. But if you run it through this, analysis tool, it'll tell you whether it was generated by an AI or by human. There are discussions around this, but I don't know of anything that's really taken off. And again, I not being an expert on blockchains, I can't really comment more than that. Yeah.
Representative Munns has a question.
Thank you. Maybe as a follow-up to that and what you had said earlier, if we were to do, or any legislature were to do any type of regulation, where should the regulation focus? Should it be on the data that's going into the black box itself, or requiring that there be some kind of human check on the output to control against hallucinations, or is it all of the above?
Yeah, that's a great question. One kind of idea that's been that we've been talking about in academic circles is creating what we call model nutrition labels. How food have nutrition labels of what goes in them. So at the very least, requiring some kind of a like a label that explains exactly where the data for this model came from. What are the potential issues with the data, all of those things. I think that would be the very least that can be done. So it won't stop the development of these applications, but at least consumers then know what they're getting, right? Right now, ChatGPT, they don't know exactly. So having what we call like a model nutrition label, I mean, it's a bad term, but that I think would be very useful. And then the other, and by the way, these nutrition labels could be then, part of it could be having human oversight. So in order to actually get the label, maybe you need to have, some human oversight over the generation or over the data that's actually used to train these models. And the other area which I think would be useful to look at, and this is a little bit for selfish reasons because I do work in academia, but I think a big issue with current advances in AI is that a lot of it is driven by industry because of the again, the resources required to create such models. And we try to play catch up, and we try to actually take a step back and analyze these models and figure out exactly what's wrong with them. But I think having I'm not sure you can force corporations to partner with academics, but having some venue, I guess way for academics to get access to some of these models would be very useful. So we can use these models like everyone else can, but we're not actually given access to the training data, to the model architecture, or anything like that. So if we had access to these, we could definitely look at some of these issues and come up with methods to mitigate them, but we don't have access to them. So access to academics, I think, would be another possible way to do this.
Representative Harrington.
Thank you, Mr. Chairman. Then you can take my question. Just a follow-up to what we were talking about with this hallucination stuff. I'm just trying to figure it. So it generates a product that comes out that may be inaccurate, but the model believes it is accurate. Now, so that presents some more results. Does that results then go back into the data package so that if a similar question or a follow-up question is answered, now it's being based on what is possibly false assumptions from the first hallucination, which only perpetuates itself and making the second one worse? Does it work that way?
That's a great question. It doesn't work immediately like that, but a big concern is exactly what you said, which is people are going to be using these tools a lot, like ChatGPT, and they're going to produce new data, and that data is going to be posted on the web. And the next version of ChatGPT is going to be using that data, and so it's going to basically have this feedback loop where, absolutely, if there are like hallucinations in the data, it could just keep getting fed back into the models, and that is a huge issue. Absolutely.
Representative Corman has a question.
Thank you, Mr. Chairman. Given that the deep neural nets are currently incapable of producing an explanation for their output, has there been research to modify them so that they can produce an explanation?
Yeah, that's a great question as well. Yes, including some from my own lab. There's been kind of two directions taken. One is what we call kind of post-hoc interpretability method. So you're given a model, let's say ChatGPT, and then our tools try to interpret how these models work. You can think of it as kind of a behavioral scientist trying to understand how dogs make decisions or something like that. That's one way. The other is to actually change the models from the beginning so that they are inherently interpretable. So instead of kind of doing this post hoc, all right, we have a model, now let's try to interpret it. What if we actually had models that were inherently interpretable? So we are working on that. It is the first area has advanced quite a bit. So these post hoc methods. The second area is a very new area of research, which is making neural networks inherently interpretable. One of the issues, as I said earlier, is the fact that it's hard for academics to work with such large models just within the resources we have in academia. And so, as I said, like if there was some kind of way to partner with corporations to give us access to these models, I think it would really speed up the development of such solutions. Yeah.
Representative McGee, did you have a question?
I do. Thank you. Yes. This conversation is just getting interesting. I was just going to say, to follow on what you're talking about now, going back to garbage in, garbage out. If the systems have this incredible exponential capability to be able to review the data, then it kind of comes down to the sort of the prime directives that are being given to it by whomever is creating these applications to put some, or maybe government really needs to play that role of trying to put in quality in terms of output, right? Because it won't do it on its own. So it has to be like a prime directive, like an iRobot, that you can't hurt humans or whatever, right? You have to maybe have government be responsible for making sure that the folks who control the data don't have so much power over that data that it then harms the citizens. So, I think from the conversation that we've had so far, I come from a systems background. I was a program manager in software engineering. And I know that unless you define the things up front that are your objectives for those applications, and unless people in government understand the objectives of each, then we may not be giving the correct inputs up front for having the applications provide what they could provide, right? We can keep them on the good path. At least it seems like that's where we're at right now, is trying to figure out how do we keep them on the good path. And I think government can interject that universities be part of the process rather than having it all be in private industry's hands, because I think you get different outcomes.
Yes, I agree with that. And, other than obviously academics having different goals than people working in the corporate world, we're more interested in, kind of scientific understanding of what's going on. We're also there's a lot of us, we have a lot of graduate students, so we can really study these systems at scale. So I agree with you 100%. And in terms of what you were saying earlier, I think an analogy I sometimes use is, you have research. Let's say you're looking at pharmaceutical research, right? So the research being done on drugs, the actual technology, right, is done in labs, and there's very little usually for the research itself. There's little government oversight. But then once you want to move that technology to a real world application like a drug, then you have the FDA basically making sure that it passes certain muster before it can be deployed in the real world, right? I think we can make a same analogy here where we can, leave the technology alone more or less, or let it develop in labs. But then once they're being moved to real world applications like ChatGPT and others, then some department like the FDA, but for AI, where they can just take these models and then they can verify it the same way FDA, verifies drugs to make sure that they're safe for public consumption. I think that would be a good compromise. It removes any kind of hurdle for technological development, but it also protects the public.
I'm going to ask the final question and follow up Representative McGee's question by asking if these applications are scraping the web for data, and we know how huge the amount of data is it even possible to control what the output may ultimately be?
The short answer is no. So we can't control it, but we can try to at least understand it and provide some insight. But yes, it's if we are going to continue relying on the web as a source of data, it's almost impossible to completely control its output.
Well, I want to thank you very much for a very stimulating and exciting presentation and discussion. And I commend you for condensing it down to a 1 hour period that we could actually get something out of. We really appreciate it. You did an excellent job.
Thank you for having me.
Thank you.
Yeah.
Mr. Chairman, will the slides be available?
Say again,
The
please.
slides that he used, will they be available?
Can you make your
Copy them?
slides available?
Sure. Who do I need to send it to?
Send them to
Okay,
Tom
absolutely.
Corman.
Yes.
Okay. All right. All right. We're going to start our next presentation in 2 minutes. If you need to go to the bathroom while our next presenter gets set up, we'll wait until just about 11 o'clock and then we'll start again. Okay, let's take our seats again, please. Okay, let's resume our activity for this morning. Before we get to our next presenter, I just want to provide one piece of information for members of the committee. You may have noticed that one of our members, Troy Murner, is not here this morning, and that's because Representative Murner resigned his seat in the House last week. So he's no longer a member of the House or obviously a member of this committee. I'm currently working with Speaker Sherm Packard to find a new member for our committee, and that person hopefully will be in attendance with the rest of us early next month. So with that, I'm going to ask Representative Corman to introduce our next speaker.
Thank you, Mr. Chairman. My pleasure to introduce Meredith Angwin. As a working chemist, Meredith Angwin headed projects that lowered pollution and increased reliability on the electric grid. Her work included pollution control for nitrogen oxides in gas-fired combustion turbines and corrosion control in geothermal and nuclear systems. She was one of the first women to be a project manager at the Electric Power Research Institute, where she led projects in renewable and nuclear energy. In the past 10 years, she began to study and take part in grid oversight and governance. For 4 years, she served on the coordinating committee for the Consumer Liaison Group associated with ISO New England, our local grid operator. And Ms. Angwin teaches courses and presents workshops on the electric grid. She is also an advocate for nuclear energy. Her previous major book was Campaigning for Clean Air, Strategies for Pro-Nuclear Advocacy. She's been a featured speaker at several nuclear events, including being a keynote for the Worldwide Nuclear Science Week in 2018. On a personal note, I started noticing Meredith popping up on my own Twitter feed, now known as X feed, and I ultimately realized that she lives in Wilder, Vermont, which is, I can almost throw a stone there. So I had lunch with her a few months ago and asked if she'd be willing to give us a presentation, and here she is. So thank you, Meredith.
Thank you very much for asking me. I'm very happy to be here. And let me see. So this is just the beginning slide, as you can see. It says who I am and where we are. And luckily for me, Representative Corman did a lovely introduction, so I don't have to write a lot about it, to talk about all this. I just want to say that I was active in the Consumer Liaison Group of ISO New England, and I also have this book, Shorting the Grid, The Hidden Fragility of Our Electric Grid, which has gotten quite a lot of circulation. I want to start by saying that my philosophy is very much that a strong grid is a reliable grid. A reliable grid is extremely important, and if you go to anywhere where they don't have a reliable grid, they'll tell you that. And the next thing is relatively inexpensive electricity, so electricity can be used for health and happiness, and electricity made with low levels of pollution and ecosystem disruption. So I just wanted to say that first, because sometimes you hear a presentation on the grid and it sounds like the purpose of the grid is to be net zero. That is something that a grid can be, should be, but it isn't the purpose of the grid. The purpose of the grid is to make reliable electricity. So here's my presentation outline. And I'm going to talk first about the physical grid and the policy grid. There are really two grids that people talk about, and they get them confused a little, or maybe they mean to get them confused. The physical grid, you can see it out your window. Okay, there's transmission, there's distribution, there's substations, there's dispatchers in the balancing authority operators room, there's linemen, there's generators, there's end users. And it's mostly limited by physics, not by regulations, what happens on that grid. Policy grid includes things like net zero, net metering, renewable portfolio standards, and so forth. And to be honest, the policy grid is mostly about how the physical grid is paid. Paid and policy is kind of the same word. So here's a situation where the two grids were confused. Vermont Yankee was a nuclear plant, and it had contracts with Vermont Utilities that ended in 2012. And it continued operations selling into the grid operator auctions until 2014. In 2013, anti-nuclear people said, you can shut it down. We don't need it. We're not even using it now. But we were using it because Vermont Yankee was putting power on the grid and people were using it. Changing a contract does not change the wires. And it's very important to keep that in mind, or you can get really misled by people who have some advocacy position or not, or people who are just confused. And as I've been working on this, I realized there's actually a third grid. And they're multiplying. It's the could grid. It's the grid you usually hear about. It's the grid that's in the Sunday paper. For example, with battery breakthroughs, we could use just wind and solar. Forget those legacy plants because something is just around the corner. Now, I want to tell you that I worked at the Electric Power Research Institute and we did research, and research does not turn into deployment very quickly. So I have concentrated on the grid we have, and I find that people know comparatively little about it compared to the could grid. So let's start with the grid we have. And I want to talk about regional transmission organizations first. I have a friend in Chicago who's very knowledgeable, went to University of Chicago with me, and she had no idea. I said to her, how is it being in PJM in the middle of MISO? She didn't know what I was talking about. But here's what I was talking about. These are the regional transmission organizations, and you can see that the PJM area was meant to be. It started out as Pennsylvania, New Jersey, Maryland. That's why it's PJM. And you notice that it's Chicago too. Meanwhile, most of the Middle West is on is MISO, Mid-Continent in ISO. Then there's the Southwest Power Pool, and the one we've all heard of. This is the one everybody's heard of, ERCOT. Anybody have heard of ERCOT? That is the grid of most well-known grid in the country. So you say, okay, those are the regional transmission organizations that operate in a certain way. What's all the white space? The white space is areas that have the traditional vertically integrated utilities that are mostly controlled by a combination of their public utilities commissions and the Federal Energy Regulatory Commission. The RTO areas have a layer of control that is the Regional Transmission Organization, and sometimes they're called ISOs. And there's a little bit of difference between the two, but don't worry about it. If it's an ISO or an RTO, it acts a certain way. So here's the two major types of grid governance. There are traditional vertically integrated utilities where the utility is responsible for reliability. It owns power plants and distribution systems. Transmission is a little more complicated because FERC is very has a lot of control, feds have a lot of control on transmission. It receives a rate of return set by regulations. That is, if it invests $1 million in a new power plant, its Public Utilities Commission will say, you can regain that $1 million from the ratepayers, and you can get an 8% rate of return on that $1 million as your profit. The Public Utility Commission has to say that, or it can't get any of that. The PUC has that control. And in an RTO area, which is sometimes called deregulated, but please, nobody is ultimately responsible for the reliability. I'm sorry to say that, but it is true. The merchant generators supply power. They are not owned by your local utility. They do not have a strong obligation to be on all the time. As a matter of fact, they aren't. Distribution utilities buy that power at auctions run by the RTOs. So, for example, if you, I don't know, if you're a rural cooperative, say, you don't have your own power plant, but you can get power two ways. You can make a power purchase agreement with a power plant, or you can get your power at an auction run by the RTOs. And the rules for these auctions and the rules for what the PUC is allowed to do and what the RTO is allowed to do, they are very complex and, in my opinion, quite easily gamed. Now, a lot of people would be mad at me for saying that, but that's okay. I said it anyway. What do I mean by easily gamed? Well, first of all, I want to show you what we owe so much to these people. This is the control room at ISO New England, and there's a control room everywhere. The name for a control room is the balancing authority. Well, it's also called the control room. But various things that the grid operator does includes paying the plants and so forth and so on. But the balancing authority is the ultimate responsibility place. They keep the demand, the amount of electricity used, and the supply, the amount produced, in balance all the time. So they're the ones who would say, this power plant has to go on now. We're getting a spike in demand. Or they would say, we're going to start rolling blackouts. Or they would say, we've got three companies that the demand's going up and we don't have more to meet it. We have three companies that have told us they're in for demand resource. We can tell them to shut down, and they will. We're telling them to shut down. So these are the people who do it. And there's several different desks. It's not just one person doing it. There's several different desks looking at things like how the gas pipelines are going, LNG tanker tracking. And the first time I was there, I was like, what's with the big TV screens? Well, the thing is, the big TV screens are about activities in the area that might affect demand. I think instead of talking about that, I'll mention the big example is Britain. Okay, in Britain, lots of people watch the soccer games, and there are breaks in the soccer games, and at that point, everybody plugs in their electric kettle. So what happens is that the grid operators are watching the soccer games so they know to order plants online when the electric kettles come on. So anyway, this is the kind of thing it's complicated to do. This is a slide that Phil Hanser used. I was giving a talk, and Phil Hanser was giving a talk, and I said, Phil, I haven't seen you for decades. We were both at EPRI together. So at any rate, let me just say this is his slide, and it shows the different usage. Okay, so you have a base load, which is nuclear, coal, combined heat and power, minimum operating letters for gas and oil thermal. There's this whole thing about minimum dispatch. You can't tell the plant to put out less than it would be stable at putting out, and some hydro. Then intermediate load, gas, oil, thermal, hydro, and then peak load, which would be gas peaking turbines, hydro, and pumped hydro, and demand response. So those are the different levels of. Okay, this is a picture of the problem that all grids have, which is varying demand. This is a pretty old picture, but it doesn't change that much. So you see the forecasted demand. I took this picture at 2 in the afternoon, 2:45. Screenshot. The forecasted demand on the ISO New England system is the blue line, and the actual demand is the orange line, and they're tracking each other pretty well. And the grid operator is using the blue line as his base, and then trying to figure out what's really going on with the orange line. Okay. Now, I also wanted to say something which is like, where is this picture misleading you? That line isn't 0 at the bottom. That line is 10,000 megawatts. In other words, the amount of power needed on the grid, it doesn't fall below 10,000 megawatts in this picture. And I think that's important to remember, because people don't, they say there is no such thing as base load. I said, well, what is that 10,000 megawatts? It's not chopped liver. So let's look for a moment at how the RTOs work, the energy auctions. The energy auctions run every 5 minutes. It's economic dispatch, which means the highest price plant sets the clearing price for all plants. So let's say that we have a plant that bids in at $20 per megawatt hour, another at 30, and plant C at 40, and the grid operator needs all of them. All the plants, A, B, and C, will get the $40 per megawatt clearing price. Now, if the grid operator doesn't need some of them, it says, okay, I need A and I need B, but sorry, C, you're out of it this time. We just don't have that much demand. Then all the plants will get the $30 clearing price. It's pretty straightforward, except that sometimes it isn't. So I want to show you a little bit about baseload. Remember, I told you that 10K is 10,000 megawatts that's on the grid all the time, that's needed on the grid all the time. Okay? So these slides are courtesy of Isaru Seneviratne, who's the founder of a group called Radiant Value Management. And it's about New York. It's about baseload in New York. So here's New York City from January to December in 2021. And the jaggedy thing is the amount of demand on the grid, which, as you can see, gets really big in July and August, right? That's the big time. That's the air conditioning time. Now, I don't like to get into what's going to happen, but if you think about we're going to electrify heating also, what do you think is going to happen to this diagram? It's going to go way up in the winter also. And you notice that he has the highest that it gets is 8,837 megawatts. And if you remember, our entire grid was getting up to 14,000 megawatts, and this is New York City alone going up to 8,000. And the lowest is 3,000. So really, somewhere between the intraday low and the minimum average, somewhere around 4,000 megawatts is needed all the time, and at peak it goes to 8,000. Now, somebody's going to say to me, yeah, Meredith, that's the city that never sleeps. What do you expect? So here is the another slide that he did where he went around to the different areas in New York City, and he put, again for 2020, but this is for a whole year. Okay, this isn't by month, this is by area. And for example, Capitol is the Albany area, Genesee is up by Rochester, Long Island is Long Island, New York City is New York City. I think it's pretty straightforward, and you can look up these areas. Anyway, that's not. The point is that the orange is what's there all the time on the grid, what's needed all the time on the grid. And the yellow is what is the jaggedy part above that lower line. Okay? So then he did an analysis of it, and it turns out New York City is not an outlier. New York City is 65% 24/7 demand, okay? But everything else is 66, 68, 61, 62. There's one that's a 54. But what I'm trying to say is if somebody says there ain't no such thing as base load, well, you can say there ain't no such thing as a free lunch either. So you do need that base load. You need the material that's there all the time. Okay, now I'm going to go on to talking about the grid in winter, because around here, that is the tense time on the grid. And I do want to be sure that I don't go over, so I'm keep looking over there. Okay.
That clock is just a few minutes fast, just to
Oh, thank
FYI.
goodness. Thank goodness. Thank you. So I wanted to show you the Texas energy crisis because it's sort of like our energy crisis, but it was much more spectacular and got a lot of coverage. So this is in 2021, and this is from the EAI, Energy Information Administration, and this is ERCOT, the one RTO you've all heard of. So it turned out that at the beginning, on Sunday, February 7th, ERCOT was doing great with 20 gigawatts of wind. Now, you understand that our little grid only goes up to 20 gigawatts of wind, okay? And that's big for us. But then the wind died down and the weather got colder. And so, as is expected, natural gas was on the job. That's what is the grid backup. When the wind dies down, natural gas is the backup. And to some extent, every time you put, until something changes, I'm not looking forward to how it's all going to be different, but until something changes, every time you put on a wind turbine, you better have natural gas around, or maybe something else like a battery. But anyway. So fuel is key for winter reliability. Oh, I have to go back to this for a minute. This drop here was when they couldn't get natural gas. The drop around Sunday night, I was actually up watching it. I knew they were going to have to shed load. It was just, they did. And they led to blackouts. One of the problems with blackouts is they planned that a blackout would last for an hour and then the power would go back on and then they'd black out a different area. That's called a rolling blackout because the area that is blacked out goes from one place to another. But actually what happened is they couldn't roll them. And so places were blacked out for 48 hours, which led to what, 200 deaths? Something like that. I don't know. So fuel is key for winter reliability. What was the problem with the natural gas? There were a lot of problems with it, but one of them is that natural gas is delivered as needed, and something can interfere with that delivery. A pipe can be turned off. There can be too much requirement for heating in natural gas, and that is fuel stored on site is key for winter reliability. So oil, coal, and nuclear reactor fuel are there. They're just there, okay? And other types of fuel can be replenished by delivery. Water behind the dam is usually just there too. Okay, so our grid operator in 2018 had a very successful program. And there's a ISO New England cold weather reports. You can find it on the web and ISO New England. At any rate, this is a report that was done on this. And this showed what ISO New England did was it said, okay, the power plants won't be able to get natural gas. We can see this coming because it's going to be very cold and there's going to be demand for home heating, and it's just not going to be a good scene. So they said, okay, we are going to underwrite generators keeping oil on site. There are many what's called dual-fired generators that can burn either oil or natural gas. And we're going to underwrite them keeping oil on site. It wasn't 100%, but it was like, we know that you don't want to do this because you can't promise to get reimbursed for it, but we're going to help you do it. So here's exactly what happened that month. I have a book, but I didn't put this in the book because everybody told me that it's invisible. The green is the oil that was purchased through the ISO New England Reliability Program. The little blue at the top is generators that didn't have the ISO Reliability Program and also purchased some oil. So that program kind of worked, you know? Okay. It was near failure, though, because this was also from the same report from ISO New England. Oil depleted on site. It started out, they could get 9 days worth of oil, and then but they only on the 1st of December had like 8 days worth of oil. Then things began getting really cold, and they weren't able to get gas, and by the 9th of January, they had 1 day's worth of oil. Well, it worked, it warmed up. Also, oil can be delivered more easily than natural gas if it's being used by homes for heating. So here's so far, I have been very much just the facts, ma'am. I tried to give you just facts. I'm now going to be opinionated. Get ready. My feeling is there's a fatal trifecta for a grid. There's over-reliance on renewables that start and stop at their own schedule, like when all that wind died out in Texas. And backing up the renewables with natural gas delivered just in time through pipelines. And things can interfere with that delivery. It can be routed to homes. There can be freezing valves, all kinds of stuff. And the third part of the trifecta is, well, we'll get some from the neighbors. Let me tell you, the neighbors are having the same weather you're having. And I first noticed this years ago when I was just writing a blog. I wasn't writing my book. I hadn't joined the Consumer Liaison Group. We had a real cold spell, and all of a sudden we were getting about half the energy from Hydro-Quebec that we usually get. Hey, wait a minute, guys, you're supposed to help us. No, they had their own problems, and they could not send us more than they usually sent. As a matter of fact, they sent less. And in the winter, the report that I mentioned, if you look at the footnotes, the winter operations report that I've quoted before, you look at the footnotes, it turns out that Hydro-Quebec makes a capacity supply obligation that's about half of what they usually send us. So when they stopped sending us as much and they sent us half, they were not violating anything they had promised. So natural gas is a just-in-time delivery, and on an ordinary day, our grid runs around 50% natural gas fired. In winter, power plants compete with homes for natural gas, and people run space heaters, which increases the need for electricity, and that's how oil comes to the rescue. I mean, I have two of those. Sorry about that. What did I put two of them on there for? Okay, New England. After that, you would say this is a really good story, and it ended happily, but FERC said no. Your renter reliability program is not fuel neutral, it's not market-based, and so you have got to think of something else. So there came 2 more programs which are both in place now, pay per performance and inventoried energy. There are different bases for these two new programs. There's the legal it isn't a matter of like oil on site, okay? They're more complicated. But, you know, I think that some of these places are really good at providing complex situations for lawyers to argue about. So I don't mind. I mean, I'm not a lawyer, and my beloved aunt, may she rest in peace, was a lawyer, so I'm not anti-lawyers. But every now and again, I think, is all this necessary? Anyhow, there's the new programs, the capacity markets is a pay for performance, and that is that if you are called on when the grid is stressed to put your plant online and you don't do it, then you have to pay some of your capacity payment to a plant that did it. The plant that came online gets extra money and you get fined. And so that's how, and I did not get into the capacity auctions, okay? This is supposed to be half an hour and I don't want you to go home saying, well, that was something. Okay, I want you to understand what I'm saying, mostly at least. So anyway, so that's the legal construct of if you don't come online, you have to pay money to a plant that did come online. And then there's the inventoried energy program, which is sort of the rebirth of the renter reliability program, and it pays per day for fuel on site. And of course, there are rules about how much it pays and what fuel on site means and stuff. But it is basically, it isn't just a legal construct. It's about actual fuel that you can use. Oddly, only certain types of fuel are eligible. Not nuclear, not coal. And as a matter of fact, I've been reading a bunch of stuff recently about FERC and ISO New England are fighting about a little bit about whether water behind the dam qualifies or not. Apparently it doesn't. But water in a pump storage facility qualifies. This is the kind of thing I mean by, there's a lot of fun for people in these projects. Also, I would like to say that the program is not really about results, in my opinion, and LNG seems pretty key in this program. But I invite you to look into the inventoried energy program yourself. I also want to say that it's very important, fast response is important. The fastest are hydro plants and batteries, and the next fastest is simple gas turbines. However, keeping them ready for fast response takes fuel, simple gas turbines. We used to call it hot standby, but that's not considered a modern term anymore. I don't know what they call it. But basically, you can't start even a gas turbine from total scratch. And to keep it going to the point you can start it takes fuel. Steam plants and combined cycle gas plants are slower. So I'm going to look forward a little here. And I'm going to look forward a little, and I'm going to talk a little bit about the could grid, though I don't like to, because it's just hard enough to keep track of what FERC is doing about water behind what kind of dam without getting involved in assessing different technologies that might happen. But here we go. The local could grid is very heavily dependent on wind. We are hoping for offshore wind, and that's what's happening. However, in recent months, offshore wind developers have been either pulling out or calling for very high price increases. This is from Utility Dive. You can look it up yourself. And 48% for contract prices and solar prices to go up 63%. And these are mostly from New York information. Okay. because that was the information I was able to get. And I want you to know that if you look at $167 per megawatt hour, or even $102 per megawatt hour, our grid usually runs $20 to $80 per megawatt hour. Okay, so these are very high prices. Now, sometimes our grid runs a lot higher than that. I don't want to kid you. And real crunches, it can run a lot higher. Recently, last Christmas, it was at $2,000 per megawatt hour. But nevertheless, for ongoing work, not, here we're in a crisis, 102 to 167 is a lot of money. Luckily, you won't pay that money per se, because it'll be mixed in with inexpensive money from other operators, unless, of course, it ends up setting the clearing price. And I don't know that. I don't know if it would or wouldn't. That's okay. Then there's the local grid batteries. Now, I don't have a lot of cost information for batteries. I don't even think I have any. But the thing is that the biggest battery in the world at this point, according to Energy Storage News, is the battery at Moss Landing. And it has 750 megawatts of storage and 4 hours that it can discharge. This is not backing up the grid. The grid at baseload is 10,000 megawatts, okay? And I just want to say that Vermont Yankee, which was 620 megawatts and could run for 18 months without refueling, was considered to be too small to be cost effective. Meanwhile, we're looking at these batteries that can run for 4 hours. Now, they're good for many things. If there's some kind of terrible problem with one plant, they could really save the day. But people have a tendency to look at them as the saviors. Okay. So here's another. So far, I've been trying to stick to just the facts. Let me just say that I have opinions, and I think that nuclear could be a really good baseload. Remember, baseload 60-70% of energy. We get nuclear as our baseload, we're going to have very low CO2 emissions. Okay? Because we're only going to have 30 to 40% to play with fossil plants. Nuclear can be sized to the grid. Now, what do I mean by that? Okay, nuclear stores fuel on site. You've already got that part. In the old days, when grids were designed, okay, and designed to be reliable, the rule of thumb was that whatever your peak demand was, you kept 120% of power plants available to meet that demand, 120% of that demand in power plants that you had available, okay? That meant that if your peak demand was wrong, or if a power plant or two went offline, you could still do it. Now, in those days, nuclear or any plant was no more than 10% of the grid. It was not supposed to be 10% of the grid or more than 10% of the grid. So you have the giant Palo Verde plant, nuclear plant out in Arizona. Oddly enough, it supplies Phoenix and LA. It isn't more than 10% of the grid. Look at those cities. But solar acts like a mega plant. It may be all dispersed, it's distributed, it's wonderful. But when you get right down to it and the sun goes down, it all goes away. And similarly, if you remember the picture I showed you of the fun and games on the Texas grid, they're 40% solar. 40 megawatts of 20, I can't remember it now. But what I'm trying to say is the equivalent of our entire grid went away when the wind died down in Texas. It was 20 gigawatts. Honestly, I shouldn't even do this. but anyway, but you see, the thing is that to some extent, the renewables are like giant plants. You know, always it's sunny or it isn't. It's windy or it isn't. And I just want to say that nuclear can follow load. And if we were willing, right now we're running on over 50% natural gas in New England. That's what we have. So anybody who's concerned about, well, how are we going to get the last 10%? I say, hey, how about the first 50%? You know, so if we had nuclear base load at 60%, we would not have to have nearly as much fossil. And you say, well, you might still have to have some fossil. I'm like, okay, I agree. But I'm just sort of like, whatever. So I just want to say another thing, again, editorializing. The conventional statements are often about how an individual citizen is supposed to act. Make personal sacrifices. Don't eat meat. Don't keep your house too warm. Lawnmowers, why don't you have a wild lawn? Plastic straws, it's all up to me. And it's like, I'm going to do this. I'm going to change my way of living and everything's going to be great. But I want to say that, and you all know this because you're all representatives. You are all here making regulations, laws, rules. A citizen is a citizen, not a lone actor. A good citizen acts as a citizen and realizes the death toll if anything happens to the grid. There were 200 to 700 people who died in Texas just from a 48-hour outage. If you read, and I don't recommend you to read it before bedtime, Ted Koppel's old book, Lights Out, about what would happen if the American grid went down. But don't read it before bedtime. I'm telling you, it's a scary book. So let's have, I want to see us making choices that will lead to a stable, reliable grid. It's not about sacrifices, it's about choices. It can be also about sacrifices. It may be that we should keep our houses cooler, but that isn't it. I mean, everybody in Germany that's right now using a lot of lignite, okay, lots of lignite coal, they could all keep their houses cooler and they still wouldn't have a grid as clean as France. So anyway, this is about my book, and I didn't bring copies, but I guess there's a copy floating around, and I would like you to, I'm happy to hear from you, and you can write me at meredithangwin@gmail, just all squished together one word. On the formerly known as Twitter, I'm at Meredith Angwin, and there's a very nice thing called electricitymaps.com. You got to fuss around a little bit with it, but it's very good to show you which grids are actually producing a lot of CO2. And that's it.
Well, thank you. That was an excellent presentation. Thank you.
I finished
I'm gonna put you on the spot a little bit and ask you if you can help us resolve a question that we debate on this committee quite frequently. It's about transmission costs. You write in your book, the building of distributed generation, smaller power plants such as solar arrays, increases the cost of transmission. Renewable advocates will disagree with this statement. Indeed, if renewables were always available to be dispatched to the grid, this statement would be false. However, since most renewables are available only part of the time, they must be backed up with other forms of power. Therefore, transmission costs do increase. And you emphasize the word do in your text. Now, this committee debates this question frequently. If a renewable system is on the grid, then the people who consume the electricity near that system avoid transmission costs,
Yes.
theoretically. So the question always becomes, do renewables increase or decrease transmission costs? Now, you've asserted that they increase them. Could you give us some insight as to your reasoning and try to help us resolve this question.
Well, yeah. So first of all, you have the renewables are often built where people don't live. Now, I'm a fan of a relative fan of rooftop solar. Because solar, the thing about solar is it's available when people need power. Wind, it's when it's available. It hasn't got anything to do with the people need power. So, what I'm saying is that wind turbines are built where it's windy, and people aren't living there. So, for example, let's say I say to you, there's a nuclear plant here, and we're shutting it down, and we're going to replace it with, no, there's a coal plant here, and we're shutting it down. We're going to replace it with, well, if you replaced it with a nuclear plant, you could use the same footprint. You could use the same transmission lines. You could use the same substations. You don't have extra costs except the usual costs of upgrading systems that you have to do all the time anyway. Okay, I mean, you don't have to build anything new. You don't have to send people out to do scouting for who's going to be least offended if we put a transmission line here, and so forth. Okay. But if you decide that you're going to replace it with wind backed up by natural gas, well, the natural gas might be in a place where you already have transmission lines. It might not. I don't know. I can't say that. But the wind isn't going to be. The wind is going to be on a ridge or out to sea or whatever, and you're going to have transmission lines and substations that are fresh and new and expensive. One of the problems with talking about the grid is that I want to be authoritative on every subject, and I'm moderately authoritative on many subjects. But for example, I'm giving a course at Osher, and in the Osher course, I've invited Lee Cordner, whose business is helping people build transmission lines, and he's going to be a guest speaker. I wish I could kind of pull him over here and have him here. I mean, I can't. For one thing, he lives in California, and he's going to be on Zoom. And for other things, he's actually kind of shy about having things recorded and so forth because he's involved in so many actual issues. But basically, that is one of the things. And then once you get those transmission lines to the wind turbines, they're only available 30% of the time. So usually if you build a lot of transmission lines like the ones that were streaming out from Seabrook, all the ones leading out from Seabrook, you expect to have power on them a large part of the time, or it isn't worth investing. So you end up with a lot of expense. Yeah.
Okay, thank you. Representative Thomas has a question.
Thank you, Mr. Chairman, and thank you for taking my question. So you mentioned 3 types of grids, but you haven't. At least I have not had the opportunity to read your book. You did not mention grid modernization, and how would you say that fits into the trend of wanting to put more renewables out there, but people do realize that we have to have grid modernization. How does that affect that? And I'd like to add first, I forgot to say, thank you very much for a most pragmatic presentation, which I really enjoyed. So thank you for that. And now my question.
Okay. So the question is about grid modernization. Unfortunately, grid modernization covers a lot of ground, some of which I think is lovely and some of which I think is terrible. So, or at least not too good. Hate to say terrible. So some of the good things about grid modernization is that you with a modern grid, the grid operator doesn't have to wait for the phone calls to come in to say, "Oh my God, I just lost power and a tree is down about 3 blocks from here." they know where the power failed because the grid is now a little bit more, gives them more information. On the other hand, a lot of grid modernization is, well, it's going to lead to more expense for what I don't consider to be a very worthwhile results. So, for example, let's say we begin charging our electric vehicles at night. Well, I've been reading, I didn't even know this until a couple of weeks ago, but apparently our transformers expect to cool down at night. And if all of a sudden they're not cooling down, they're going to shorten their life expectancy. So are we happy because we have just modernized our grid? We've replaced a bunch of transformers with bigger transformers that maybe are big enough so that even if people are charging at night, they're still cooling down? I don't know. But what I'm trying to say is, or another thing, I am not a fan. I mean, I think it's fine for a big company to decide that it's going to participate in a demand response program because it's worth it to that company to have lower electric rates because they're in the program, even if every 2 years they have to turn off the electricity. That's the company's decision whether they're going to make that or not. I feel that the modern grid is forcing us all into demand response programs. I mean, I have a friend in California who wrote me and she said, you know, I'm a working single mother, Meredith, and I come home and I turn on the stove and I cook dinner for my kids. Don't judge me. I said, who am I to judge you? But what I'm trying to say is that she's not supposed to do that. It's a flex alert time. The flex alert lasts from 4 o'clock to 9 o'clock, and you're supposed to minimize the amount of electricity you use. So I don't know what grid modernization means.
Representative McGee has a question.
Thank you, Mr. Chairman. Thank you for being here. Really appreciated your presentation. My question is around capacity planning, because when I first started paying attention to the ISO New England and the planning that's being done, it seems like our energy systems are extremely siloed. And so the responsibility for reliability may be the bailiwick of the ISO, but the idea around what we put on or take off the grid in terms of reliability, we've had a lot of nuclear plants that have closed rather than upgrading them to new technology that could load follow. You know, it doesn't seem like there's any planning in terms of the actual problems that we're going to be facing in the future. And so the question really is around where the responsibility lies for that capacity planning in terms of, like you said, the decisions that get made, because that's the reason I'm here, is that I thought that the most important decisions the state would be making would be around you know, what we would be doing with the grid for the future and how it would be very expensive for people if we make the wrong decisions, right? If we run down the wrong roads, we're going to spend a lot of time and a lot of money undoing those runs in the wrong direction.
Well, I agree with you, and I've often said that the trouble with the RTO system is the buck stops nowhere. It has a independent market monitor who's supposed to look and see if, for example, some company owns 3 power plants on the grid, and it sees that the grid is having a problem, and it takes one of its power plants off because now the grid operator is going to have to call in very expensive power plants, and now it's going to make more money. It's not going to have to supply fuel for its cheapest power plant, and it's going to make more money. So there's the grid independent market monitor is supposed to be on the lookout for this. But I tell you, I don't think that they can watch it all. I mean, and what I mean by that is that I read a really good book, not on the same subject. It's Javier Blas is The World for Sale about traders. And I can tell you that no matter what the monitors say, the traders will get their trades done. And similarly, if there's a company that wants to get the clearing price higher and it can do it, it will manage to do it. I mean, I don't mean to be terribly cynical, but anyway, that's how I look at the world. I guess that's me. I'm cynical. But yes, the buck doesn't stop anywhere. One other thing about the buck not stopping, if you go to ISO New England and you say, where are the power plants that you should be building? The ISO New England will say, resource adequacy is the state's business. How many power plants are built is the state's business. We just dispatch them. I'm like, huh? You also set up the rules for who gets paid how much. That's a little bit of a responsibility. But anyway, that is something I wanted to say. Okay, I've talked too long. Yes.
Representative Munns has a question.
Thank you, Mr. Chair. Thank you for coming in. I'd like to come back to the conversation we were having with you about transmission costs. And I will accept, your premise that if you were to replace a coal-fired plant with a nuclear plant, you wouldn't have to build new transmission lines. I completely agree with you there. And I would also agree that if you install wind turbines offshore, you're going to have to build new transmission lines. So there's going to be a transmission cost increase. But isn't that only half the equation? Because the cost of actually building the wind turbines is going to be significantly less than the cost of building a nuclear plant.
No.
And
turbine.
And the ongoing operating costs, for example, or a solar farm. I mean, yes. I mean, maybe the transmission costs go up, but don't we have to look at the total costs?
Actually, there's been a lot of work on that, and I don't follow it as close as I should. But basically, what happened is back in the day, Lazard Brothers used to write a thing called the levelized cost of transmission for different types of power plants, and it was always coming out with, solar's nuclear, wind is great. Well, people began saying, hey, we put wind on a grid, and almost always the cost to the consumer goes up. And so Lazard has recently gone back, and then other people were doing calculations on what they call system costs. That is, you put the wind on the grid, and then you have to make sure there's gas plants on the grid, and also a nuclear plant runs for 40 years, no problem. 60 years, no problem. I don't know if it's going to run 80 years, but what I'm trying to say is that your average wind turbine is restructured after 10 years. Now, the reason for that is a little more complicated. This is the whole policy thing. But basically, wind turbines get what's called a production tax credit, which runs out after 10 years. But they can reset the clock by doing a major overhaul. So I don't really know whether they could last 20 years if the production tax credit lasted 20 years. It's the policy and the physical are very confusing. But I would say that a wind turbine is out there in the wind, in the atmosphere. It's a delicate piece of equipment, and it really isn't going to last for 60 years. And so you have to look at that.
A follow-up. And I was only using wind as an example of a renewable fuel. I mean, solar is another renewable fuel. My point is that to argue that renewables are going to drive up the cost of transmission, therefore they are not worth investing in, doesn't seem to hold water, because the capital cost and perhaps and certainly the operating cost of some of these renewable projects is going to be a lot less.
The capital cost, if you look at running a renewable project for 40 years and replacing it after 10 to 20 years, is per megawatt hour is not as low as you might think. Okay, and I encourage you to look at Lazard Brothers and Tom Stacy, who does a lot of work on that. I didn't say they weren't worth building. I mean, I think that I personally think that nuclear baseload plus solar and natural gas following would be a lovely, lovely low carbon, low cost grid. But I'm going to tell you right now that remember the first slide, reliability is first. Reliability is first. I'm sorry, I wish I had some kind of deep voice and something bang on but basically reliability is first, and wind turbines may have zero fuel costs, but you can't count on them when the going gets tough.
Okay, Representative Harrington gets the last question, and then we have to wrap up.
Thank you, Mr. Chairman. Thank you for taking my question. It was a very informative presentation. Try to get a little bit out of the theoretical and maybe a little bit more into the practical. I don't know how versed you are in this, but if you do have an opinion on it, I'd like to hear it. The two Mystic power plants are going to be closing next June. They're RMR plants right now that won't be extended. They've already announced they're going to close down. That's 1,400 megawatts of power we're going to lose. But because they take about 60% of the offload from the Everett LNG facility, it looks like the Everett LNG facility is also going to close. Now, I was recently at a FERC ISO New England winter assessment meeting and looking forward, and about half the people there said, we've got to do something to keep the Everett LNG facility going because we don't have enough natural gas in the winter, and we also need it for back pressure on the natural gas pipelines. And the other half said, no, we can probably get away without it. Do you have an opinion one way or the other on that?
I wish we were keeping them. Yes. I mean, I'm sorry, but there's a lot of wishful thinking about we can probably get away. You understand that a systems engineer shouldn't be saying that. I mean, that's not the best way. Now, I understand that people really, really don't like them, and as a matter of fact, I think it's sort of shameful that we have to get LNG cargoes from Tobago to run our grid. I mean, I think that's a shame, and I think somebody should go over to New York and shake them until they let us build a pipeline to the Marcellus. But I just want to say that I watched that meeting also. And I have to tell you that I don't travel as much as I'd like to, so I watch a lot of meetings on Zoom. And that's the way it is.
I've just tell people in the wintertime, especially when you go home at night, pray that there's no industrial accidents in Tobago, because if there is, we're out of luck for power.
Yes, that's terrible. It's bad for a big, rich industrial country to be dependent this way.
I agree, and thank you very much for your presentation here today. It's really been a treat to have you here, and we're really grateful that you came, and we hope to see you again sometime. Thank you.
Thank you.
All right. We are officially on lunch break now until 1 o'clock, at which time we will take up our retained bills. So we'll see you then. Okay, everybody, please take your seat. We're going to get started here very soon.
Serious. Well, was it serious? What's that? Serious. Yeah, my car's outside. It's smashed.
Well, you got whiplash from getting rear-ended?
All right, everybody, let's get started. This is the 1 o'clock session of Science, Technology, and Energy. We are going to have a full committee work session on our retained bills. And here's what we're going to do. We're going to go through each bill one by one, and we're going to decide whether or not we need to form a subcommittee. If the answer is no, then we move on to the next bill. If the answer is yes, then we form a subcommittee. We ask for volunteers to serve on the subcommittee, and I appoint a chair for the subcommittee. The chair of the subcommittee will then go to the subcommittee members and discuss potential future meeting dates. Once you decide on potential future meeting dates, then the chair will go to Carrie, our admin, in the staff office to schedule a subcommittee meeting. Now, the presence of members of a subcommittee is required at a subcommittee meeting, but any ST&E member, or in fact, any member of the House, can attend a subcommittee meeting, according to House rules. The subcommittee will then deliberate on what should happen with the bill. If it's decided by the subcommittee that an amendment is necessary or desirable for the bill, the subcommittee will create such an amendment and bring it to the full committee when we convene to pass judgment on all of these bills collectively. So that will be the procedure, and hopefully we can get through these 12 bills fairly promptly. Anybody have any questions about the procedure? Representative Corman.
Thank you. I just want to verify, are you planning that we would do an exec on all 12 bills on October 31st?
Not October 31st, but a day to be determined later.
And we would exec all 12 together?
All 12 will be done on the same day, yes. For convenience purposes. Any other questions? Okay, let's get started. First bill is House Bill 159. I suggest that since this bill is unconstitutional as written, that we consider ITL as the motion for this bill. Now, I know some people would expect that we would want to try to do something about the spiking cost of energy. And Representative Bernardi has filed a bill for this, or an LSR for this upcoming session, to allow laddering of default service procurement. So Representative Bernardi, could you discuss the particulars of your bill?
The LSR is not yet written completely. It's with OLS. However, the concept that I gave them was right now we have contract requirements that go every 6 months, and when the utilities go out looking to fill those contracts, they're subject to largely the costs that are available in the market in that unique time window. With the laddering concept, they could have contracts that go anywhere from, I suggested 3 to 9 month period. And I asked OLS to look at other states, how they're doing it. And so we could use those as examples in preparing that language. So that's what's being developed right now.
Mr. Chairman,
Okay,
just a
comments.
quick comment on that. Actually,
Representative Harrington.
in the past, that was how the rates were set. There used to be, like Unitil or whatever would have a contract, and it would have half of their load for a certain period, another half. So all the load would not come up due on the same date like they are now. So there is a precedent for doing this. And I'm sure if we look back, we could figure out how it was done.
Well, the next question is, did it work?
You're dealing with averages, so it all depends. Sometimes it's going to come out beneficial, sometimes it isn't. It's like if you looked at this past year, when Maine does it on a yearly basis, we do it on 6 months. Ours went up higher, and everyone, oh my God, the prices are much lower in Maine. But then when the prices went down and we were able to adjust quicker, no one made a big deal of the fact that the prices were going to be higher in Maine for the next 6 months. So it minimizes the ups and downs, but it probably doesn't change the total cost very much. It just means you're paying, X amount of dollars, more closer to the same amount every month, rather than have it go up 120% of X and then go down to 80% of X. So I don't think it changes the totals that much, but it does it avoids those big bumps in bills.
Representative Thomas?
Thank you, Mr. Chair. Yeah, I want to reiterate what Representative Harrington said. I think the key is that the laddering can soften the blow, shall we speak. It's so that people have a more consistent monthly payment versus getting shocked every so often. So to me, I think that's an advantage. People at least have a good expectation of pretty close to what they might be paying every month, except being surprised with big jumps and so forth. So
if the purpose of the original bill, HB 159, was to average default service costs, I think it was 5 years, Representative McWilliams?
Yes, the intent of the original bill was to allow up to 5 years and this was as amended. It was attempted to be amended the day it was presented. There was an issue where this committee did not allow amendments the day it was presented, but that was the presented amendment, was laddering up to 5 years. So therefore, your term could be very short, say 2 months, 3 months, or it could be a 5-year, to create a pie chart mix where you have some very risky and some very not risky investments in long-term and short-term together, which, as Representative Thomas acknowledged, then therefore averages out the overall cost, and we don't have surprises for our constituents who receive a bill in the winter that is just crazy expensive.
So it is an averaging bill, and as Representative Harrington just explained, laddering is also an averaging technique. So the question then becomes, should we go with the laddering bill and either interim study or ITL this bill, or take another path? Representative McGee.
Thank you, Mr. Chairman. Well, I think our recommendation would be that we ought to pass as amended the bill that was submitted under HB 159. But you had alluded when you opened the session that the bill was somehow unconstitutional. And I thought maybe you could speak to that piece of why you have exception to the bill. And I didn't know whether you were talking about the bill in its original form or as amended.
I think I was talking about the bill in its original form. And I recall, and he can correct me if I'm wrong, that Mr. Licata from Eversource testified that averaging over 5 years would deprive the utility of the ability to recover its costs in any given year, potentially, which would be a violation of the takings clause of the Constitution. Is that correct, Mr. Licata?
Thank you. Yes, that is correct. The issue becomes when the cost that the utility incurs by procuring the power is different than the cost that the utility is allowed to recover So if it's, again, just speaking to the original bill, if it was a 5-year average of regional rates, let's say that was 10 cents, but the utility went out to purchase the power from the market and let's say that was 12 cents, essentially the utility is unable to recover the costs that it incurred to provide service to the customer. So as Chairman Vose said, that would constitute a taking under the Constitution.
Okay, thank you very much. Further discussion on this bill? Okay,
Yeah, just
Representative McWilliams.
just to be clear, I'm advocating for the amendment, the 159 as amended. I think we all agree that there were issues with the underlying bill. But I think that there is something here that's worth working on with the amendment, certainly for laddering. And it sounds like Representative Bernardi has already put something into OLS to start the process for next year. So having a working group now might be a really good idea because we could have a nice bipartisan discussion about all of these options and perhaps even weigh in on the proposed legislation before it's finalized with OLS so we can have a really good bipartisan consensus coming into laddering for January rather than waiting until January to see what OLS drafts and then having to create a subcommittee within this committee February, March to do the same thing that we could do now in the next couple of weeks. So what I'm proposing is we go with the amendment, and even if we vote yes or no, we'll still have the opportunity to work together on laddering now. Thank you.
Okay, so can you refresh our memory about what the amendment contains? Because I just looked in the folder and there is no copy of the amendment in the folder.
Yeah, just give me a second to pull it up.
Mr. Chairman, while she's looking at that, I just wanted to make one other comment on this.
Go ahead.
The bill, I don't know if the amendment addresses this, but this talks for using the 5-year average of retail rates from the New England region, which would mean it would be based on things that are happening outside of New Hampshire, which we have no control over. I'm not sure I want to be allowing things that Rhode Island does to set the electric rates in New Hampshire, because they could do things that would drive up the retail cost, but maybe at the advantage of the people in Rhode Island, but nothing to New Hampshire. So I think that's another issue here. And also, there's been a lot of discussion lately over looking at a different way of procuring completely, like going to the market, sort of like the way the co-op does, or some modification of that. And I think there's a report coming out of DES in, I believe it's December, either the beginning or end of December. They're supposed to address that because there was a preliminary study done by the PUC that said if you looked back over the last 5 years, I think they went back 2 5-year groups, and you looked at what the actual LMPs were as a basis and compared to getting contracts, you would have saved money going that direction. So that's another thing that could be considered in this upcoming bill as well.
Representative McWilliams.
Just to be clear, that 5-year piece was proposed with the original bill, not the amended bill. The amended bill doesn't look to other states. The amended bill is just about New Hampshire. Yeah, so what I'm proposing is we put together a subcommittee to talk about laddering, because I think it's important that everyone who's concerned about electric rates and laddering have an opportunity to discuss that and potentially have some input on this proposed bill for next year. The timing is right. I'm not saying that I want to pass the amended bill, but I'm also saying let's not throw out the baby with the bathwater and wait another 6 months before we address this. So my proposal is let's have a subcommittee, let's talk, let's come up with some recommended best practices. And whether the recommendation from the subcommittee is, yes, we love what we talked about, let's pass it as further amended, or no, I don't think this bill will work, but we're going to come up with something excellent that can work for next year. I think the timing right now makes sense for us to have a subcommittee to work on it. And that's what I'm pitching. It's not about original 159. It's not even about 159 as amended with the language related to New Hampshire's wholesale market, which is it's a very broad term about New Hampshire, but it doesn't relate to Rhode Island or any other state. I think really what we want to do is just have some good fact finding now so that we can be prepared for when we start again as a committee in January. And that's my pitch. That's really what I think we want to do as responsible legislators to our constituents and to the electric market as it is. Let's bring in some experts, have really good testimony. Let's discuss pros and cons, and let's come up with a strategy for laddering for next year's bill. Thank you. The amendment is 2023-0557H as in horse. Yep.
Any further comment on whether or not we should form a subcommittee for researching this issue? Representative Notter.
Thank you, Mr. Chairman. With our limited time and so many bills to consider, I think it's better to start with a clean bill in January than an amended one.
Any further comment? Seeing none, I'm okay with forming a subcommittee to study this question. Do we have volunteers? I need at least 3. Representative McWilliams. Representative Bernardi. And Representative Wendy Thomas. And Representative Summers. Anybody else? Oh, Representative McGee. All right, I think that's enough members of that subcommittee. I will appoint Representative Bernardi to be the chair of that committee, and you guys can get together and figure out when you want to start meeting. And just recall or remember that you'll need to wrap up your work on or before October 31st. The executive session will probably be in early November. I'll have to look at the House calendar to be sure exactly when our final date for dealing with this issue is, but okay, that takes care of 159. Next is House Bill 166. Okay, next is HB 166 relative to the elimination of useful thermal energy from renewable energy classes. I think the recommendation for this bill is ITL. Does anyone have any further comments on it? Representative Harrington.
Yeah, I realize this bill isn't going anywhere, but it's, I guess, call it my pet peeve. I think the people of New Hampshire, ratepayers, should know what they're paying for, and paying for somebody to heat a factory that has nothing to do with electric rates shouldn't be subsidized by the electric ratepayers, but it is. I realize it's not going to pass. Just ITL it, and I just request don't put it on consent.
Okay. Any further comments? Seeing none, we will move on to House Bill 175 relative to the state's energy consumption goal. Once again, this bill has come before us before and didn't gain any traction. I suspect ITL might be the best way to go here. Any comments? That's the bill where you changed the word fossil fuels to greenhouse gases.
This was requested at one time by the Department of Energy. I haven't heard much back from them on it, so I guess it's not a big deal.
Okay. Moving on. HB 176 relative to the rules of the Site Evaluation Committee. Pardon? Yeah, we haven't taken a formal vote, but the recommendation is ITL at this point. HB 176 relative to the rules of the Site Evaluation Committee. Representative Harrington, you have a comment.
This is what is it, 176? I don't have it in front of me. I believe this is the one that basically says, make the rules fit the law. And I'd like to see this go forward. There was 5 or 6 years ago, maybe longer than that now, there was a bill passed that put a lot of additional restrictions on wind power. It was right after the Antrim wind projects. And the law basically said these apply to wind projects. And when they wrote the rules at the PUC at the time, put those restrictions and requirements on all energy projects. And that simply was overstretched what they did. I wasn't in the House at the time, nor on the PUC. I tried to get involved and was basically told by a senator on Jelcar, no one knows what they're talking about anyways. We're not going to waste any more time on this. We're passing the rules as is. So this would simply say, and I guess it would probably be directed back to the Department of Energy now, go fix the rules to match the law. And it's pretty straightforward. I would think everyone would be in favor of not allowing agencies like the PUC to create legislation. They should implement what is passed by this House.
Additional comments? Representative McGee.
Yeah, well, I appreciate the explanation from Representative Harrington. I think that sounds vague, being put, asking DOE to modify the rules to fit the law. And so I think that if that bill were to go forward, it would require, I think, more specific instruction from us in terms of what is intended, because it seems like there are a lot of other things that could be ratified under something that's as vague as that. So I would still be in favor of ITL.
If I could respond, Mr. Chairman?
Yes,
There are
Representative Harrington.
specifics in the bill directly. It says, in order to amend the rules pursuant to Section 1 of this, the committee shall include, but not limited to, the following. And it lists site rule, the specific rule requiring the committee to conduct an adjudicative hearing, blah, blah, blah. And then it says another site rule 30105, and then another site rule 30108, and site rule 30108C4. So it's very specific. It lists the different places where they have to change the rules.
Does
So
it
it's not
does
vague.
it say what they are?
It lists the rule right in the bill. And you can go to the thing, it says this requires all energy facilities to have an emergency response plan. There is no such requirement in RSA 162H. They just made it up. So it's very specific in the bill.
Well, to follow up on Representative McGee's question, starting on line 3 of the bill, it says, no later than 60 days after the effective date of this paragraph, the committee shall initiate a proceeding to amend adopted rules Site 100 through Site 300 to ensure that no authority is assumed to the committee that is not specifically authorized by RSA 162H. But then Section 2 only mentions 1, 2, 3, 4 specific rules, all in the 301 section of the rules. So I think the reason this bill didn't get traction earlier, Representative Harrington, is because it seems to be directing the Site Evaluation Committee to do a review of rules that's quite extensive, even though the bill only wants it to look at 4 specific rules. Is there a way to tighten it up and make it, are these the only 4 rules you think need to be reviewed?
Well, it says shall include but not limited to. I could live with just having it do these 4 ones, because it's certainly better than having none. Because having these things like an emergency response plan for a solar facility is kind of ridiculous. It was never the intent of the law. We have trouble enough citing things in New Hampshire, and having committees make up requirements that aren't in the law only makes it worse.
So would the committee be open to accepting an amendment on this bill to restrict the Site Evaluation Committee rules review to just the 4 rules listed in the legislation currently? No comment? Representative Lewicki. Well, it would obviously mean that the Site Evaluation Committee administrator, who happens to be in the room, would probably have to take on this responsibility, or at least to guide the committee to doing this activity. Any further comments? Representative Bernardi.
Thank you, Mr. Chair. Yeah, I think the administrator could readily take on the 4 identified items and propose those to the a full committee the next time they met and address this issue. I agree that if it's expansive, going through sections 100 through 300 and everything contained therein, that's a bridge too far.
So Representative Harrington, would you be willing to create an amendment to restrict the bill to just those 4?
Sure, you just have to take out a few words. There's no problem with that.
Okay. So going forward, then, it looks like what we will do with HB 176 is OTPA, unless there is further comment on that question. And Representative Harrington will prepare an amendment on this bill. Okay, good. Next is HB 3.
Mr. Chair, can we make sure that's circulated before we have the exec?
Excuse me?
The amendment, can we just make sure it's circulated before we have the exec so we don't have to learn
Yes.
about it there?
Good suggestion. Representative Harrington, could you circulate that amendment sooner rather than later? Thank you. Okay, HB 381, relative to solar generation under the renewable portfolio standards. This is a bill that kind of undoes what HB 549 did. I'm not sure it would gain much traction. I suggest ITL. Any further comment?
Mr. Chairman,
Representative Harrington.
I'm a little confused. I've got HB 381 relative to solar generation under renewable portfolio standards. Then on the other list over here, I've got HB 381 relative to system benefits charge. So is it just 2 different names for the same bill? Okay.
Yes, you're right. It is relative to the system benefits charge.
And this has to do with whether it can be changed with, by the PUC or some other one, but would require that.
But my
prior-
original comment still applies, that this bill essentially undoes what HB 549 did and didn't seem to gain much traction within the committee its first time around.
But what is HB, the one you just mentioned, 549, what did that do?
You see the language that starting on line 8 all the way down to line 16 that has been struck out?
Yep.
That's language that HB 549 added to statute. HB 549 added a lot more language to statute, but that language is essentially the crucial part of the bill and what it created and established.
All right, I guess this is getting nowhere, so let's just get rid of it.
Okay, so we'll probably go with ITL on this bill. Next is HB 548, relative to participation in net energy metering by small hydroelectric generators. This bill was identical to Senate Bill 40, which we passed and the governor has signed into law. So this bill is no longer necessary. So I recommend ITL. Any other comments on it? Seeing none. Next is HB 509, relative to phasing out the minimal electric renewable portfolio standard. This bill, as written, calls for a phase out of the RPS by 2028, I believe. But it presents us with an opportunity to create a study committee to determine what's going to happen with the RPS after 2025. Because right now, as written, the RPS statute kind of stagnates in 2025. And 2025, although it may have seemed at one time to be a long way into the future, is not that far away. So I'm of the opinion that we might want to use this bill as a vehicle to study what's next for the renewable portfolio standard. Now, that may be too much of a job for a study committee that can only meet for 2 or 3 weeks. but it could result in an amendment to this bill that essentially says, let's form a study committee to see what happens to the RPS after 2025. Thoughts, please. Representative Harrington.
You know, the intent of this bill was, as just like it says, is to phase it out. For those who weren't around when the RPS came out, it was we needed to give the renewable energy a boost to get it going because it was in an infantile method of producing electricity, and it needed help to get going. And eventually that was never supposed to be permanent. Once it was up and running, we've certainly seen a number of solar and wind projects and other renewables now. We also have the production tax credits and the investment tax credits, which have been extended for probably forever under the crazy bills passed by Congress. So my intent on this was how long do we got to keep giving this, holding up the hand of the renewables? I think it should be phased out, especially with all the federal tax breaks they're getting. So that was the intent of the bill.
Thank you. Additional comments? Representative Kaplan.
Yeah, I can understand the the feeling for the need for eventual looking at the continued subsidy of renewables. I mean, it's, you know, it was implemented with the idea that that this infantile industry, as you said, would need some sort of boost, and does it still need that boost? I think it's an open question, and it's an interesting question. I don't think we're ready to answer that question as a committee here. And if we wanted to deal with that issue, we would really need to look at it in depth and in, you know, a long-term study. So I think I agree with the chairman. I think that it warrants a study committee, but I don't agree with the intent of the underlying bill that we would be studying, because I don't think we're ready to declare that the RPS is in need of elimination. So I don't know where that leaves me, but I am in favor of looking at it as a study committee.
Further comment? Representative McGee.
Thank you, Mr. Chairman. I think in our conversations as well, I mentioned to you that currently this committee asks that the Department of Energy provide us with a report on the status of the RPS each year in October, I believe it is. And we don't do a lot with that information that we receive already, right? We don't make an assessment of whether the RPS is operating as we would like it to, or if we're meeting our goals or should increase our goals or lower our goals. Or, I mean, nobody lowers their goals, because that's the point of the RPS, is to really measure what you're doing in terms of penetration of various types of clean energy. But I think that we should probably make an effort to look at the information that we already have and absorb that before we go forward with trying to certainly not eliminate it. I mean, we would have to have a good reason to eliminate it. And I don't think the fact that there are federal subsidies trying to help people figure out how to implement cleaner sources, I don't think that that's a reason for us to do away with a program that basically is designed to help us keep track of what we're doing in those sectors and make it easier for DOE, for example, to measure how we're doing in those sectors. If we take away the RPS, then the measurement goes away. So I'm opposed to moving forward with it. I'm not opposed to a interim study on it, but I think ITL is probably appropriate. And if we are going to look at the RPS, I believe you, Mr. Chairman, have filed something on the RPS in the LSR system. So I think we'll have an opportunity to look at it further in the coming year, but I don't think we need to keep this one alive.
Since you brought it up, I will mention that I have filed an LSR to change the renewable portfolio standard to a clean energy portfolio standard, because I wanted to start that conversation. So I have filed a bill to give us an opportunity to do that. Representative Harrington, did you have something else?
Yeah, I don't want to stretch out a big argument on this thing, but, you know, my point is that this was never supposed to be a permanent subsidy to people. And it's also, I don't think you can pick up a paper, or if anyone picks up papers anymore, or put on the internet or watch the television, whatever, without being constantly bombarded. But we're all going to die from global warming in a couple of weeks. So everybody in New Hampshire knows about global warming and carbon emission and zero base and all this. So the fact then comes down to we consider them too stupid to make that decision on what type of electricity to buy. Because if they're all worried about global warming, they'll all go out and buy renewable energy. You can go to the PUC website and you can select someone to give you 100% wind or wind and solar or whatever else. And all I'm saying is I think people in New Hampshire are smart enough to make that decision. They're no longer ignorant of the problem because they've certainly been inundated with it. And we shouldn't, as the state, be saying you're too dumb to pick out the type of electricity you want, so we're going to pick it out for you and force you to buy something that you don't necessarily want.
So we have this kind of a conflict with regard to the bills we're discussing here. When we talked about HB 159, we talked about trying to do something about the high cost of energy. And yet, on page 233 of Meredith Angwin's book, she cited information from a 2015 study by energy tariff experts, which revealed that renewable portfolio standards in New England costs varied from 2 to 3 cents per kilowatt hour in Maine to 1.1 to 1.6 cents per kilowatt hour in Massachusetts, with other states falling in between. She goes on to further state, the ratepayers, nobody calls us customers, pay these overhead expenses. The price rises caused by renewable portfolio standards are significant. Those are her words. So here we are talking about trying to bring down the cost of energy, but we've got a program here that actually drives up the cost of energy. So I'm wondering if there is some way we can reconcile those two conflicting points of view, Representative Partial.
I think reconciling them is essential, what we're here for. However, I would this time suggest that forward, rather than try to turn this bill into something it's not, and just give this bill the ITL.
Representative Kaplan.
Yeah, I think this conversation is quickly spiraled way beyond the scope of the bill that we were supposed to be discussing. So before I agree with the Representative Partial. Before I go any further, we should just ITL it.
Representative Harrington.
I don't think the bill's going to go forward again. I just want to let the word out to the people of New Hampshire of what they're paying for on the electric bill. I have no problem with ITL as long as it doesn't go on the consent calendar.
Representative Lewicki? No. Representative McGee?
Yeah, my comment was really just a comment that you made about sort of that there's a cost to the RPS. There's also a benefit to the RPS, which is the reason that we're doing it. And so, those are the kind of conversations we can have when your bill comes around. But since this bill's premise is to phase out the RPS, I think we should just let it go. We're not going to agree that that's something we want to do right now with the retained bill to pass that into law.
Further comment? Seeing none, we'll move on then.
What was the decision on that? Is it ITL?
We're not going to form a study subcommittee.
Oh, I mean, okay.
And then we'll discuss the outcome of the bill in executive session. Next is HB 558 relative to microgrids and electric grid resiliency. Now, I know that the prime sponsor of this bill, who is Representative Keith Ammon, has been working with the Department of Energy and the utilities to come up with some amendments to the bill. And apparently, from what I've heard, I was hoping Representative Ammon might be here today, but he's not. So from what I've heard, the amendment language may address the concerns of both the DOE and the Department of Energy. So the question is, should we form a subcommittee to study the amendment, which I'm sure we can get a copy of promptly, or should we just wait until we see the amendment and then decide what to do? Thoughts? Representative Thomas.
Thank you, Mr. Chair. When are we expecting to see the amendment?
I don't know the answer to that, but I can find out. Representative McWilliams.
Thank you, Chair Vose. Speaking as an engineer and someone who thinks linearly and also with a little bit of strategy, I think it makes all the sense in the world to form a subcommittee. And if we can't get a copy of the amendment, just don't meet. But the alternative is the amendment is still under discussion and we don't form a subcommittee. So the first time we see the amendment is when we're voting just before October 31st. I think strategically, it probably makes more sense to form a subcommittee that may or may not meet. Thank you, Mr. Chair.
Additional comments? Representative Wendy Thomas.
Yeah, Representative McWilliams has just changed my mind.
Further comments? I'm okay with forming a subcommittee. Who wants to be on a microgrid subcommittee? Please raise your hand. Representatives Thomas, both.
Don't make it confusing.
Representative Wendy Thomas and Representative Douglas Thomas. Representative Tom Ploget. Representative McGee. Anybody else? Oops. Okay, so we have Doug Thomas, Wendy Thomas, Tom Ploget, and Kat McGee. I'll appoint Doug Thomas to be the subcommittee chair. Okay. Pardon?
It's only 4, right?
It's only 4 people. That's all who volunteered. So let's, subcommittees make recommendations. So if you can't come to an agreement about your recommendation, then you just tell us that. And then the rest of the committee will decide what to do. Okay, so HB 609 relative to energy facility siting. As you will recall, House Bill 281, which was heavily amended by the Senate, implemented some of the reforms that were contained in House Bill 609. But there very likely are other reforms that we could make to the Site Evaluation Committee. So I recommend that we form a subcommittee to see what else can be done with HB 609. If we strip out the 6 or 8 pages of stuff that's already been implemented in law, it'll be a much smaller bill, much more compact. So I recommend a subcommittee to study that bill, and I will volunteer to be on that subcommittee. Any other volunteers? Representative McGee?
Mr. Chairman, I just wanted to make a comment. We had 10 members of our committee at the New Hampshire Energy Summit, and that was on the 18th. And there was a panel that discussed Site Evaluation Committee changes that they would make. So I think we have some good recommendations to bring to that study committee. And I'll volunteer to be on it as well. And I have the names of a couple of other people who also already said they'd be interested if you need more names.
Representative Kaplan, you're volunteering to be on the committee?
Yeah.
Representative Harrington? Anybody else? Representative Corman? Anyone else? Okay, I will be the chair of that subcommittee. We have 1, 2, 3, 4, 5 members. So we will proceed with that one. That brings us to House Bill 616, relative to administration of the New Hampshire's Renewable Portfolio Standard. This was a bill by Representative McLean to add nuclear to the Renewable Portfolio Standard. And we didn't think the bill at the time that we passed judgment on it and retained it. I don't think we believed that the bill was ready. There were too many unanswered questions about how this whole addition would work and affect the RPS. So the question now is, should we form a subcommittee to study this issue? Or should we study this issue when the LSR that I've submitted to change the renewable portfolio standard to a clean energy portfolio standard comes before us.
I vote for the
Thoughts?
latter. I vote for the latter.
Okay. Representative Summers.
Does your clean energy LSR include nuclear?
Yes, it does.
Okay, thank you.
Okay, so we will ITL this bill then? Is that likely to be the Representative Harrington?
Yeah, on your bill, does it, this, I believe this bill, and I haven't looked at it in a while, the one we're looking at right now, also basically just takes the renewable energy and lumps them into one, gets rid of the class system. So it says somebody can go out and this is how much renewable energy you must buy. You figure out whether it's going to be solar or wind or qualifying hydro or whatever. Does the bill you're proposing do that as well?
Well, as Representative Bernardi said about his laddering bill, the details are not nailed down at this point.
Okay.
I can certainly add that to the bill, or we could consider moving forward with this bill, taking out the nuclear part and just considering the collapse of the classes in this bill. Anybody have any thoughts on that idea?
I would think it would be cleaner to just do it all at once with the bill coming up next year than try to work with two separate bills and
Okay,
it
that
just
seems
gets
to
too
be the
complicated.
consensus. All right, so we'll probably ITL this bill then. All right, next is HB 622, repealing the Energy Efficiency and Sustainable Energy Board. As you'll recall, House Bill 281, as amended by the Senate, did that. So this bill, as it exists or as it is written, is no longer useful, but I suggest that we amend the bill by replacing the language in the bill with language that encourages the Grid Modernization Advisory Group that was created by Senate Bill 166 last year to add energy efficiency to its responsibilities. We have language that has been offered to us that does that, and I suggest that that might be the best way to go with this bill. Your thoughts? Representative McGee.
Yeah, I'm in favor of that.
Additional thoughts? Representative McWilliams.
Are you proposing a subcommittee to discuss the language on the amendment, or you just want to float an amendment that we can see early before,
Yes.
before the 31st?
I'm proposing that we float an amendment.
That sounds good.
I'll submit that amendment this week, and once OLS prepares it, I'll send out the amendment to the committee. Okay. And last but not least is HB 631 relative to electric utility smart meter gateway devices. So this bill is a bill to allow customers optionally to purchase smart meters from their utility. I guess the language of the bill states that it has to be a smart meter that the utility approves of. And so the question becomes, do we want to allow this? Would it make a difference? Would anybody take advantage of it? Would anybody spend the extra money to buy a smart meter, even though they might not get much use out of it? Or do we wait until the utilities decide how they want to use smart meters? Representative Thomas.
Thank you, Mr. Chair. Mr. Chair, we've gone through several of these type bills over the last several years, and they haven't really gotten too much traction. A lot of, like what you said in terms of waiting for the utilities to come out with something. There's been questions about the definition of what a smart meter really is. There's been concerns about health effects. There's been concerns about privacy effects. Yeah, I think I would be in favor of just ITLing this bill.
Other thoughts? Representative Lewicki.
Thank you, Mr. Chairman. I agree with Representative Thomas. I don't think that this is really a matter for legislation. I think this is something that can be between the utilities and their customers. And if the utilities become invasive or invading privacy or so forth, then it may be an area for litigation rather than legislation.
Additional thoughts? Representative McGee.
I had a bit of a hand in the original bill, and I can tell you that and I wasn't here when it was presented because I was out, but the original intent of the bill was to make it non-mandatory but optional for customers to be able to upgrade the technology that they have in their home to a smart meter if they choose to. And the idea is that the utilities would have to decide what grade of meter and what type of meter would be appropriate for people to purchase so that they would be able to contribute to the infrastructure that we will be moving to in the future. Because I think that information is already known, and all of the utilities in New Hampshire are not in the same place in terms of the upgrade of their infrastructure so that it has the technical capabilities to do certain things that we'd like to see them do in the future. And my thought was, if a migration to smart meter technology ends up being mandatory or being adopted by the utilities in the future that are not there yet, then that would be a very expensive cost shift to the ratepayers. So the idea of allowing people to, in a voluntary way, people who are early adopters and who just like technology or want to be able to have access to that information, if they were able to invest in that technology, which is a relatively small cost for a homeowner, in advance of a major migration, then we would be upgrading the technology by people's opting in, basically. And so the idea is not to wait for a mandate that we're moving everything, which will be expensive and a cost shift, but to at least make the technology, which is now available out there, something that's promoted through the utilities so that people can opt in if they'd like to and purchase it.
Further comments? Representative Harrington.
Yeah, just wondering if the representative from Eversource would like to comment on this.
Eversource did testify in opposition to this bill originally. Representative Ploget.
Thank you, Chair. There is also groups out there that do not like these smart meters. We hear of them. They're worried about their EMF output. So I would like to not advance it, so ITL.
Other thoughts? Representative Thomas, Doug Thomas.
Thank you, Mr. Chair. Well, I do agree with the intent of the voluntary nature of this bill, which I think is more to my liking in that respect. I still think that this bill would be premature because there's really nothing out there yet, and the utilities certainly aren't proposing one yet, and we run a risk of a few people buying something now where maybe in 2 or 3 years it's surpassed by different technology. So I think it's a little premature in that respect, although the voluntary nature of it, I think I always want to keep.
Representative Partial.
Thank you, Chair. I think we already had an opportunity to weigh in on the electromagnetic output of these smart meters where the bill came up earlier. We all decided that that was insignificant. So to bring it up now, I find a little bit disingenuous. I would also add that I do not like the bill as written. I think that we have early innovators in the state, such as Unitil, who've gone to smart metering, committed to it fully, and they have actually created the software to have time of day transactional time of use billing. I think that has to be the wave of how we're going to modernize the grid in order to flatten our demand line and flatten the curve, and to basically reduce the cost of our electric to our consumers. I think to ITL this is a bad move. I think we ought to actually instead perhaps have a study committee on it. It might not be the best bill, but I think it's a bill that certainly deserves our attention and can be improved. Thank you.
Further comment, Representative Wendy Thomas.
Thank you, Mr. Chair. Just to talk about a statement you said, or a couple people have said about waiting for the utilities to make a decision. There's no incentive for them to make an immediate decision, and I think that part of our job is to light fires under them to force decisions for the customers.
So how does this bill do that? It's optional. so.
It's kind of independent of this bill. It's just the statements that were made around here. I mean, I would like to see smart meters become available for those who want them, the early adopters. I would put one in my house.
But without some kind of a utility program to take advantage of the smart meter, what does it buy you?
Right, but for us to wait for the utilities to tell us when they're ready to do it, I think that that's kind of backwards. I think we should be demanding of the utilities that they put in this kind of technology.
Wouldn't
even
buying
if
the
it's
smart
only-
meter without a utility program to take advantage of it be like buying a computer with no software?
No, I don't think so.
Representative Lewicki.
Thank you, Mr. Chairman. There are, in my experience, numerous ways that people can monitor their power usage real time other than using the meter itself. You can have some kind of current sensors on your wires, whatever, and I'm certain that such things exist. And if somebody wants to do it, then they can do that without any privacy risks and without having to wait for the utilities to do it.
That's true. My utility, New Hampshire Electric Co-op, offered me the opportunity to buy such a device. I think it was $259. And it would monitor all the appliances in my house and tell me what I was using. Representative McGee.
Yeah, I just wanted to clarify because the idea that only the utilities would be able to help you to use a smart meter's output is inaccurate. There are applications you can have on your phone that help you interact with your meter, and those can also be used by groups like the Community Power. You know, we're starting to create a competitive market in New Hampshire. Having a smart meter is not only a utility for a customer. Maybe utility is the wrong word, but only helpful to a customer if they have a utility to interpret it for them. I think the data is something that is not necessarily just going to be a construct of the utilities going forward. So I think that's a misnomer to feel that you can't use it if your utility isn't ready to help you read it.
Representative Wendy Thomas.
Thank you, Mr. Chair. You left us hanging. Did you buy the smart meter?
Say again?
You left us hanging. Did you buy the smart meter that was proposed through
I
the
did
co-op?
not. I did not. No.
Okay, thank you.
It was a good deal, but I didn't buy it. I don't really care how much electricity my refrigerator uses, so. Okay, further comment. All right, I don't sense a strong desire here to form a subcommittee on this one, so we'll just have to let this one go as it will when we get to executive session. And with that, we have gone through the entire list. According to my notes, we have formed 3 subcommittees, one for 159, which consists of Bernardi, McWilliams, Wendy Thomas, Summers, and McGee. Then we have formed another subcommittee for HB 558, which is Representative Doug Thomas, Representative Wendy Thomas, Tom Ploget, and Representative McGee. And the last subcommittee is HB 609, Representatives Vose, McGee, Kaplan, Harrington, and Corman. Is that correct, Representative Doug Thomas?
Thank you, Mr. Chair. Mr. Chair, I propose that whoever we get as our new committee member be put onto my subcommittee.
Okay. If he is so willing, I'm willing to appoint him. What's that, Representative Wendy Thomas?
Or her.
Or her, yes, correct. Okay. I think we have Representative Notter.
Do you know when you're going to have these subcommittees?
As I explained at the beginning of the session, the subcommittee chairs will decide when to call a subcommittee meeting, being well aware of the fact that it has to be published in the calendar at least 4 days prior to the meeting. So for example, if you wanted to have a meeting, subcommittee meeting next Monday, as long as you got it into this week's calendar, then you could do so. But it's going to be up to the subcommittee chairs to schedule these meetings, working in conjunction with the members of the subcommittee. That makes sense? Seem fair? Okay. All right, any further business to come before the committee? Representative Ploget.
Thank you, Chair. I'd like to make an announcement comment about the study committee on assessing generation. Thank you. 4 of us from ST&E are on the, it's a commission to study the power generation as assessing. The chair, Pat Abrami, looked at it and what he'd done the years before and would like to extend this committee so we would have enough time to complete it. Right now it ends in, I believe, November, pardon? Oh, I'm sorry, November 1st? Yes. Of this year, 24. Is it 23? Yeah, I'm so sorry. Of 23. So we're going to need more time. He was asking if ST&E could renew this committee for another year. That was to 25, November 25. Also in discussion, renewing it is by either adding it as an amendment or using one of the ITL bills to extend the study commission. In our discussion, Representative Munz recognized that there's 4 of us on ST&E on a commission that's really assessing the value of these generations. There's not much power being talked about. It's just how do we assess the infrastructure? So it was brought to us 4. I think we have a agreement that 2 would be enough from ST&E. You know, 4 is an overkill. There's a Senate appointee, and maybe Ways and Means. I will let maybe Mr. Abrami decide, but I think we had a consensus that 4 from ST&E is too much for the next. If we make a bill for extending it, so that would be a change. Thank you.
Representative Gorman.
Thank you, Mr. Chairman. Yeah, if I may just add on to what Representative Ploget said. The commission, as it currently is constituted, has 5 members of the House, Representative Rochefort from Ways and Means, and then 4 from this committee, Representatives Munz, Summers, Ploget, and myself. And what we're looking at is how to assess these properties for taxation. And, you know, this is just not in the wheelhouse of people from this committee. It's in the wheelhouse of people from Ways and Means. So what we're thinking is that if we do put through a bill to extend the life of this subcommittee to sometime in 2024, excuse me, not subcommittee, commission to sometime in 2024, that the bill also recommend at least a certain number from Ways and Means so that the people who actually know how to deal with taxes are properly represented.
Okay, so let me ask the committee, would you guys be open to the idea of creating an amendment to extend this assessment commission and modify its membership, and using House Bill 458, which we were going to ITL, as the vehicle to do that? So we could replace all of the text of 458, including its title, and extend the assessment commission's life until November of 2024? Is that a long enough time?
It should be, in theory.
In theory, okay. What do you think, Representative Doug Thomas?
Yes, but thank you, Mr. Chair. Yes, I agree. And one major reason why I agree is because the 4 representatives that are on this commission right now weren't here a few years ago when a similar tax assessment bill came through our committee for electric utilities. And although we did a valiant attempt during that 1 year, we quickly advised when it came through again, it needed to be going somewhere else because, as the gentleman stated, we are not tax assessors. And just because it has the word generator or utility or energy doesn't necessarily mean it's in the proper committee. So I really support an amendment to make those changes because I don't want to go through this again because we're not tax assessors.
Representative Harrington.
Yeah, this issue's been going on for, I don't know, the 20 years I've been involved in the State House. So if there's a chance they need a little bit more time to finish it up, let's finish it up and get it done. So I strongly support giving them the extra year.
Further comments, Representative Munns.
Yeah, thank you, Mr. Chair. I just wanted to follow up and say that, the reason for trying to do it with a bill that we are talking about right now is so that hopefully what we can do is get it expedited through the House, through the Senate, so that the amount of period that will lapse between when the commission expires on November 1st and it gets to start up again will be very short.
And that's why an amendment would work, correct? Okay, any further comment on that? Seeing none, we will proceed that way. Could I ask Representative Corman and Representative Ploget to work on said amendment and send it to the committee as soon as you can get it prepared by OLS? And you can certainly work with Representative Abrami too, or former Representative Abrami to make sure you get it right. Okay, any further business to come before the committee? Seeing none, I think we're done. Adjourned for today, and we'll see you soon. Take care.